Good morning, everyone. Let's just check we're live. I hope you're all doing great. We are going to be rushing down the BRDF through the filament documentation today. I hope you're all up for that. Let me just share this on my Discord. So we are improving the BRDF lighting, hopefully, by slowly progressing through what's considered almost basic stuff, but you know, because I've learned random things over the years. So let's just get let's get up the documentation that we're going to be reading through. So how we're going to do this is we're going to go through each oh, I haven't got the chat open, let me get that. We're going to go through each section of this. It's actually quite nice to understand. Some of the stuff I'm going to skip if it's not explained very well, so I can look it up later. So I'm going to keep taking notes. I did a bit of revision today, just before the stream, but I think I'm going to show off just where we're up to. So if I bring up my project, so we can see the chat is now open. We are, if we have a look, so I quickly hacked together these, which I'm not going to actually use for this, because we haven't technically worked this out yet. So this was more for testing purposes more than anything. So I'm going to remove them just briefly. And oh, I actually have it already open. Fantastic. Okay, so yes, this was more because I was running out of time yesterday and I wanted to see. So we're going to write these ourselves rather than just rely on copy and pasting, which is bad. But anyway, this is where we got up to yesterday with our directional light source. So, oops, let me just work out what's going on here. These two, yes, these need to be removed, which I'll just comment out briefly. Okay, so we have, if I disable the model, we have a poor man's directional lighting. Now everything's facing, the light is facing the wrong way on all the models because it's not accounting for the rotation, but that's something we can easily fix, so I'm not that worried about it. We might fix it today even, but effectively this is where we're up to. We are lighting the scene through our directional light. It actually looks way better than I expected when I did this, so that's kind of cool. But yes, we're going to improve the BRDF that's being done on the calculations, so we can actually see you know, what's going on a bit more and be able to fly around the scene and stuff like that. So yeah, it's going to be a bit of a study stream, but we're going to rush down as far as we can go. A bunch of lighting calculations that we need to do, and make this scene look a lot nicer. So yeah, it's so for those who don't know, there is this tutorial / documentation that talks about someone else's renderer, right? And we're going to be following this all the way through, because I feel like, despite it being a renderer just for Android, the amount of stuff that's actually in here is actually quite impressive. We probably won't use literally everything in here. Some of the stuff is probably Android specific, like we saw earlier on today. This is dealing with the D part of the BRDF when it comes to the normal distribution. What is it called? It's actually called something. Normal distribution function. Okay, it's just function. The NDF, right? So this is doing some. This is dealing with half precision with this Langraids identity here. So we don't have to do a lot of different things that they're doing, because they're having to target like earlier Android devices. But the fact that they were able to pull off some of the effects they did on Android is actually really impressive. So we're going to be following along as far as we can go. There are things like this which I don't, just to talk about some of the maths. Some of the maths is poorly explained in the sense that it just kind of goes, there's a function here, we did the approximation here, right? So there's some stuff like that we're not going to do. But how we're going to do this, by the way, is we're going to do a bunch of typing, and then we're going to fix the, I wonder if I can get rid of this. Can I do that? Yes, fantastic. Okay, so what we're going to do is excuse me. We're going to go through this. We're going to type up a bunch of maths. We're going to understand what's going on. We're going to look at other resources, etc. And then we're going to go into our engine, and we're going to fix some of the BRDF stuff. I'll do that later. and we're slowly going to go through and get more and more advanced. I hope today, this is a bit of an ask, but I hope that we at least get to, let's just see, I want to at least get the reflectance in, because it would be nice to be able to do this kind of thing, right? And maybe conductors, but we'll see if we get that far, right? I also need, so I at least want to get to something like clear coat around there. So I'm going to be kind of going hard today, trying to make this work. I'm writing things down. The anisotropic modeling, probably not. It looks a bit, I was hoping to get actually all this done in one go, but, and to get to lighting, but that I think is going to be a bit intense, when it comes to, but yeah, that's what we're going to be doing today. I hope you're up for that. It feels like, I know I said this on the Discord briefly, that because I've been studying like offline ray tracing, and we, as you probably saw on the few streams that we've had, and scroll back up to where we were, and I had been doing mesh shading with Tasker mesh shaders, culling things, which I mentioned in my coding for 1,200 hours video. I did that for about a year, but I never actually did this, right? I've never actually learned the relevant information that's needed to to build up a proper lighting BRDF, so which stands for bidirectional reflectance distribution function, which effectively, if you don't know what that means, is it allows us to simulate light bouncing off it allows us to simulate two parts of the of a light beam, the diffuse, which is like non-shiny surfaces. So this could be like I don't know, think of something like a matte finish on a car maybe, or like an unfinished piece of wood. Like the amount of light reflected off that is going to be really low, so it's not shiny at all. And then the reflectance part that gets added together with the diffuse part, which is this. And you can think of this as like the most extreme case of a reflectance surface would be a mirror, but we have stuff in between, like ceramics and I don't know, something that's more reflective like some metal, something that's less reflective like I don't know, some plastic, I guess, like plastic technically has. So what we do is we combine them both together, right? So we have like a more accurate we have a more accurate lighting simulations per point. So we're going to try and rush this down and get as far as we can through this, because I really should know this, right? This is something that I should know this type of thing, but like I said, because I've been studying some stuff that's like I don't know, considered niche / more advanced. I'm not sure. We have studied stuff that's too advanced, I guess that would be the accurate description. So yeah, let's dive into it. I have actually prepared today, so I won't have this moment where like I did last stream, where I ended up taking forever to eat my lunch. So I actually got my lunch ready. And yeah, let's dive into it. So here's the thing I'm going to do initially. So I was thinking about this particular code, right? The simplification of this is nice, I guess. Right, so okay, so this is what I got stopped on yesterday. So yeah, I'm gonna kind of go as fast as I'm gonna lock in on this. Oh, I haven't even started the music. Let me get the music started for you guys. Make sure this is randomized and check the levels are good. Yeah, okay. Fantastic. If it's too loud, let me know, and I'll always quieten it or louden it depending on what you guys want. And yeah, let's go. So I think it's better to have like some nice background music. Yeah, but I hope you guys are all doing well, by the way. So yeah, let's kick ass with this, eh? Okay, so this. So I'm gonna X. I feel like M is a bit. It might be. It's a bit loud for me. This, so I'm gonna turn this down personally. Okay, just a little. Okay, so this lambda. Function works out the height of the microfacets. Facets. Right. No, that's how you spell microfacets. Is that microfacets? I feel like I'm typing microfax. Yeah, I feel like. hang on. Let me just scroll up to absolutely make sure. I feel like I've learned how to spell it wrong. Give me one moment. So microfacets is brought up at subsurface scattering, micro level. So I think it actually has microfacets E. Right. And I've just noticed I spelled it wrong here as well. Let's just do a quick search and replace for this. So find micro fax. Yes. Yes, microfax. I don't know what that would mean. But let's at least go that. It's still a little loud. This song is quite quiet relative to the other songs, so I'm aware that all of a sudden we might get like really, really loud music from another piece of video game music. Okay, so normal distribution. What have we got? So blah 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 blah. Okay, so microfacets. The height of microfacets. This is the formula, which is, I think I just said function earlier, so that's just an equation with an input. Okay, so lambda, lambda. So yeah, hopefully we get like some cool, some cool lighting effects today, which we can enjoy. It'd be nice to see. So 1 minus. Yeah, so this is a bit loud. So oh, it's fine. It's fine. I've turned it up on my end. No, it's still loud. Trying to work out these things for you guys. We want it to be there, I think. Yeah, thank you for bearing with me with this music. It's important, like I said. It's very important to me that you guys have a good listening experience, considering there's no outside of me coding and taking notes. There isn't any visuals, so I don't want you guys to suffer because I've decided to put on some loud ass, music that I like, and you guys are trying to like get something done on your end. So yeah, it's very important for me to get that working for you guys. So tangent. I actually have not in all of graphics so far. Hi, Moshi. Monshi. Hope you're having a great day, dude. It's good to see you, my man. Theta. Theta. So hopefully we get some good lighting effects today that we can. I'm quite excited. I'm more awake than I was yesterday. I was quite tired yesterday, which led me to be a bit less disciplined than I usually am. But I'm kind of for it now. I'm kind of ready to crush it as best we can. Right, so I'm not going to do what they did with the maths because this is kind of a... We can convert the tangent function with some trigonometric identities. So yeah, I think it's originally sine over cosine is tangent, but we can change cosine sine into cosine with a -1, which is nice. So that makes sense. But yes, now we're going to go and type this out ourselves separately with an equals there. 1 minus... This is such a funny YouTube recommendation. I just started I just started Vulkan a few weeks back. Nice, bro. I'd love to hear it. Hopefully you're enjoying the Vulkan process. I know a lot of people sometimes struggle early on. But it's great. It's great that you're, you know, going down the Vulkan pipeline like me. Yeah, because I know sometimes it's a bit tricky. So one, nope. What is it? I feel like it's not. Did I type that in wrong? Hang on. Oh, that's why it's complaining. I was confused. That's why it's complaining. Yeah, we'll be doing a little bit less Vulkan for now, but I think eventually... Oops, let me... Eventually we'll get back into hardcore Vulkan, because I want to eventually do GPU-driven rendering. And for those who don't know what that is, that's a method of... no, I'll just do frac. That's a method of telling the GPU what is it? To do draw. Sorry, this is super loud. It's very distracting for me. I'm gonna turn it down on my mic actually. Okay. Oh yeah, that'll solve that problem from on my end. So what it does is it's gonna tell the GPU to do their own to generate their own drawing commands, right? So instead of me having to tell the GPU, you know what it should draw on the CPU, it is going to we're going to tell. Oop, I meant to do theta, not 0. We are going to tell the GPU what the draw commands are, and it's going to blast through them on the GPU, which is going to be quite. That is going to be quite Vulkan heavy. There we go. Right. Okay. So let's grab this. Don't need to do this twice. All right. Cool. So we should have that. Then we do this fraction, which is just 2. Fantastic. We can replace the because at the moment that is the. By the way, if you're wondering like how you do GPU side culling that and dynamic LOD, you have to do that with can I just paste this in? Yep. You had to do that with GPU driven rendering. Because you have a compute shader basically that culls things based on like some criteria. So yes, eventually we'll get back to like proper bashing our head against the wall when it comes to figuring out how to handle buffers that have come from the GPU, and we need to send them out again. Okay, so as far as I can tell, oh, I see what he's done. Hang on, let me I kind of didn't realize. Okay, so theta. So it's actually that what he's sent in, right? Oh, no, he hasn't. Okay, no, it is X. Let me just get the maths right. Because the maths is... all this applied mathematics is, you know, how we get good lighting. Okay, so let's go one more. So lambda and actually, what am I doing? This is just an equals again. Equals 1/2. No, it is. We have a different variable. So lambda of, we'll do v because that's the v is the what is this called? This is the view vector. So frac. Despite this being pretty heavy with the maths right now, I feel like compared to doing ray tracing / path tracing on the yourself, oh my goodness, this is like so much nicer. Squirt alpha squared plus 1 minus alpha squared. So this is just us to the power 2 simplifying the cosine and sine part of the algorithm, which I assume there's a lot of maths that's happening here, but I have a feeling that this was just kind of brushed under the rug more for the sake that to the power 2 to get you through the documentation faster. So this isn't quite a tutorial, sadly, so it's not going to explain this stuff, like how it derived the result, but I'm just going to link an article at the end, because this is what I was thinking, right? I don't want to end up getting stuck on this for hours and hours and hours. Oops, wrong way around. It's on the inside. Just because I need to read a paper on microfacet theory. So from that we get the derived visibility function. So where this documentation has decided to be very short and stuff, we're also just kind of skip over it, because I need to, you know, as someone who wants to be a good graphics programmer / engine dev, like, I need to understand this and get through this quickly. I can't just be on here forever. But at least this explains the... okay, so I'm just going to steal... I think what I want is not the fraction, but the... okay, no, it's all different. Never mind. Right, so n.l L. I think actually this repeats. Okay, so we only need to write half of this and then change some things, I think. Oops. C dot V to the power of 2, 1 minus alpha squared. So now we're going to write, as soon as we've written this function in C++, we're going to write this in our shader and just kind of improve the lighting model as we go, which I'm quite excited to do. So alpha, which is nice, squared. A lot of alpha squareds in here, but I think we can probably get away with, no, we're still on the side, the fraction. So what I'm going to do is steal this, kind of add it twice. And, okay, that didn't work. What do I need here? That should be good. What is happening? Oh, it's overwritten. Oh, no? Okay. Oh, okay. There we go. Okay, so we at least got that written in, I guess. And now we can do the square root, I think. So we just take this. It's inside the square root. Is it all under the square root? The plus is not, though. Okay, so this is pretty awkward, but I think what we need is this. Okay, that makes more sense. And then this will work if I take the square root. Okay. That's what I got wrong. Okay, I think it's gonna work, assuming I don't get rid of the plus. Yes. So this is NV and NL, and it is still 1 minus alpha squared. Okay, fantastic. The GLSL implementation shown in listing 3 is a bit more expensive than we would like, since it requires 2 square roots. This requires... Okay, so the music has repeated. Yeah, almost instantly. Interesting. Okay, so give that a second. Go next, and hopefully that will load. Filaments, thank you. This requires 2 square roots. That's how you spell square. Which can be expensive. Again, because this is on some GPUs, I don't think that's going to be a concern for us because we're not after mobile hardware. So yeah, we'll just type this up. So V underscore Smith GX correlated. Oop, my laptop's about to die. Correlated. Okay, so we have n.l, n.v, so n.v even, so normal dot vision, and then float normal dot light, float roughness. Okay, so float alpha squared, so alpha 2 equals roughness times roughness. Why do you keep doing that? Fantastic. Scroll down. Okay, so float ggxv equals NOL times squirts. Alright, cool. So n dot v times by n dot v times by, so this is the denominator. If you, so a alpha 2 plus alpha 2, and this is almost the same except for the, it's not n dot l, it's n dot v. So n dot v and then n dot l to l, so it's just these the same, just flipped, and this is all divided by a half. So you could multiply by a half, but yeah, this is cleaner. So I wonder if there's a situation where the where the denominator in this case returns 0 and we get like some kind of undefined behavior on the GPU. I can't imagine the addition makes any difference, but we'll still add it the right way around. So I'm gonna say visibility. I like visibility. Visibility. I like kind of being a bit more explicit with my code rather than using math notation, you can probably tell. So let's go into our shader and improve our, and we're not going to use this because that's the slightly, no, we do need this still. I said the distribution, this is what it stands for. So distribution. Okay, so what are you complaining about? So syntax error expected, unexpected reserved word float. Oh, yes, you're right. There's a missing comma. All right, so let's throw that back into the here. So if I look at this again. Okay, so the visibility, so they have the distribution GDX, which I believe I just called the same as the source code. So I'm going to take that, and this time we're actually going to build up a so specular vec3 specular equals, so this isn't the full specular, but it's getting closer, times by the visibility. I don't think we need either, so I think it's fine to just multiply them both together, and it's pretty obvious that we need roughness, n.l and v.l, right? So we're going to throw this in here, and roughness, which I believe is... Oh, we don't have the Fennel index. Okay, so this needs to be... Fair enough. Okay, so right now this is going to have to just take the... because we haven't worked out Fennel yet, so we're just going to multiply by the specular. And call it specular for now, and then eventually we'll work this out. So, so right now we just have the specular lights, and luminance. Yeah, so we have the distribution now. We have the visibility function, and that should improve our specular highlighting. Let's have a look. Based on our distribution. Right, so let's turn off the lighting. So I think in general it's going to look darker and darker until we decide to increase the lumens. So yes, it's just got dark. I don't really, because it's a really low amount of there isn't that much specular highlighting on all these models. I think it would make a difference if we loaded in a model with lots of specular highlighting on, rather than just diffuse, because that would be quite dark. So in general, I'm not that worried. It does show that there are specular highlights on this model, which is what you see when we see it at a distance. The artist has put specular highlights on the actual thing, so you can see it when you get close. Yeah, it is quite dull still. And the direction of the light is this way, right? So for all the models, we need to obviously correct the rotation of the light, but that's fine for now. Okay. We have got at least further along, and I think we're basically at the end of this, maybe. We can optimize the visibility by approximating after noticing that all the terms under the square root that are all sums are in range of 1 to 10. This approximation is mathematically wrong, but it saves 2 square root operations, which is good enough for real-time mobile. Okay, so I will just throw this in. Hammond 17 proposes the same approximation based on some observations that the square roots can be removed. It does so by rewriting the expression as a lerp. Okay, so there's two optimizations that you can make for speed while reducing the accuracy. If you care about the square roots. Okay, so what I'm gonna, I remembered on this site we can actually get the most of the LaTeX, if I remember how to get it. Yeah, I just remembered then. Is it this? Yeah, I think this mostly gets everything, but it's not quite. It's not going to be quite correct, which we can easily fix. But it'll get us like 80% of the way there. Or if you want, actually, I need to say this bounds assumes that all the terms of the square roots are within the a range of 0 and 1. Yes. Okay, so this is only really needed if you're targeting mobile GPUs. Alright, so I'll put it in here just kind of as a fun. I think I might just make a new note actually, so what did I call this? For mobile GPUs. So instead of, I'm just going to make this kind of like a, alright. Let's correct the maths here, so this is quite easy to fix. So this is n. Oops, not n. Sorry, this is n. And then c dot l. So that needs to be in here. And this is a V, so just change this to V. So NV. That's the V. There we go. Yes, that's on the outside. We add these together. So yeah, if you're working on a mobile GPUs, there you go. And let's type that out. Or you can also do the same with a lerp. Okay. That's not a thing. I'll just type it out normally. Linear interpolation function. And again, we're just going to grab the LaTeX. This website actually does the LaTeX. So it should... This is to hopefully speed us up and get further through the... oops. So it's going to take me a minute to get the right thing consistently. But this hopefully will speed us up. In the long run. Okay, so we have n.l. We do have this though, we can just grab, so n.v. Oh, come on. Delete this. n.l. And that should fix the maths. So the faster version of this is in GLSL. Okay, so I'm really excited to get to the Fennel section because that is something I do not understand very well. So I'm glad I've got through that, which is nice. So what I'm going to do is just kind of rob this, kind of, because it's effectively the same. Yeah, let's put fast at the end. Okay, so we obviously don't have these, the square roots, and we have a bunch of stuff we have to change. Okay, so we have roughness, but that is now not alpha squared, that's just alpha. Okay, so roughness, GDX, we have n.l, and inside this we have this, and then we get rid of the middle factor. And we have alpha, 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 alpha. Sounds good. Okay, so we've done that. We've improved our modeling. We've improved our lighting just a touch. But now we are on the Fennel. So let's. We have two functions here that are kind of dense. So let's geometrics. Let's at least split these up a little bit. So what I do after a section like this, for those who are watching for the first time, I make sure that when I've written something, when I'm taking notes, that I connect it all to other pieces of information that I've already learned as part of the learning process. And it's also important that I break things up due to the fact that I'm never actually going to read this, right? So if it's a big massive, 5,000 words, sorry, note that I've taken, I'm not ever going to read it, am I? So, physically based rendering, so I'm going to take in the, I'm so excited to get through this, because it's stuff I should know. I should know this, but I don't, so it's kind of sad. But we've just got to push hard and get through it as fast as we can, so we can catch up with other people, and where I should be, relative to other people when it comes to this stuff. So, but yeah, We just got to imagine that every day we just get better than the day before, and that's all that matters. Okay, fantastic. And next we need the mobile version, which I'm definitely going to split up because this is... So yeah, if you're wondering what this is called Obsidian. Which it helps build a, it's like it helps build notes into like a Wikipedia style documentation, I guess. So yeah, we definitely need to have this as a reference, otherwise we won't know what's going on. Hi, Bot Red Gaming. Said this. I assume you've also started Vulkan then? Seems like a lot of us are all on the Vulkan train recently. Yeah, we don't need to know about Monte Carlo stuff right now. Yeah, still on the graphics theory myself, but we're slowly improving our rendering, which is nice. I think what I'm going to do is also have the normal distribution here as well. So, and obviously we need to go this way to the GPU stuff. What is bidirectional What is the bidirectional reflectance distribution function? Okay, so yeah, I can explain that. Good question, by the way. It's if you're interested in something called physically based rendering, which tries to take the real world, like the physics that lives in the real world, and accurately reproduce them in your game engine or slash GPU stuff. So if you are learning this, so what does that mean, right? What does that mean? So we can scroll up here. Actually, it's got a great picture. So we have the light source here, which is L, right? And this bounces into a point on, I don't know, a tiny pixel of what you need to render, right? And what this BRDF function is trying to replicate is how light scatters when it hits something, which is this green, which is called diffuse light. This would be something that would look like rough wood, matte surfaces. That's like you can imagine if you look around, you probably find in your own vicinity something that isn't shiny, right? And it also combines that with the reflectance part of light, so stuff that reflects. You're probably very familiar with what that means, like a mirror, or you know, metal is quite shiny. And what it does is it combines them together, so we can get something like plastics or ceramics, which are a combination of both the diffuse light, the green, and the reflectance light, the blue here, right? So the reason it's called bidirectional as well is so if we were to stick in light that was going in this way, going to the camera, we could then do it the opposite way and get the same result, right? Bidirectional means that we can fit it in either way. Reflectance is what I just talked about, working these two out. And the distribution is just distributed over the surface, right? So we have lots of I think it's distributed over the surface. So that's what we're doing here with the BRDF. So there's a bidirectional reflectance distribution function. It's despite the math is not that complicated. It's literally just it's like three functions. It's like the code is like this long. There's a couple of extra things I need to add in here, but it's about 2 extra functions, and then you've got the BRDF, like a standard BRDF. The harder part of the BRDF is actually representing the specular light, which is the reflective light that we just talked about like a mirror. The rest though is pretty straightforward if we use like the Lambert's diffuse, which is just multiplying your base color by 1/pi. Very, very simple. Which means all light gets equally distributed in every single direction. I'm gonna use a pi because it's, you know, if you know about unit circles, it's like halfway around a unit circle, right? And so we distribute it over the whole of that semicircle slash, but but it's in 3D, so it'll be a hemisphere, so half a sphere. That's why it's 1 over pi. Anyway, so yeah, that's what it is. Thank you for asking the question. I hope it's not too confusing, the title. But yeah, it's if you do want to do physically accurate lighting, there's this documentation here that can teach you how to do it. And you can see the functions are very small. Like, it's not, the coding in the fragment shader is actually quite easy. But understanding it and getting it accurate, on the other hand, is kind of hard. Because there are many things that can influence it so it looks accurate. So we're just slowly going through each section of the function, which is split up into four things: the Fresnel, the diffuse, the Lambert diffuse. We have the visibility function for the reflectance, the distribution function, and the Fresnel function. They all come together to make the specular. So I'm on the Fresnel part now. What would determine / cause non-uniform scattering? So that would be the Lambert diffuse scattering here is not accurate, right? It's very rare that a surface is completely uniform when it scatters light, right? So if we look at this image here, the real reason that light is scattered, if I go up here, is because this is actually what the surface looks like of a rough. Like, you can imagine, the rougher a surface is, the more like small little things like this happen. And if I scroll down, there's a better picture of what I want to show you. So that's like the zoomed in, but we can zoom in even more, right? This is actually what it looks like really zoomed in, right? And we have light that comes in, and sometimes on this tiny crack here, it gets like blocked, and on here it gets blocked this way. So this is called, when it bounces out and it doesn't reach the camera, it's called masking. And when it bounces in and it doesn't hit the surface where we want, it's called shadowing. So this causes a tiny shadow, and this catches the light here. This is why it's not uniformly distributed in real life. So we build up models that are kind of approximations of this over time. And there is one in here that I can actually show you further down. I think it's not, it's past the Fresnel. So Disney, the actual animation studios, has come up with like a slightly more accurate. So this is the diffuse, the Lambert diffuse model here. And this is the Disney one, right? And you can see that it's got a darker shadow here, because it's more accurate to what a purely diffuse surface would look like, how it behave under a directional light, whereas here is a bit less accurate. However, you can get a completely uniform scattering and get basically the same result, right? The code is more expensive because you have to do this per pixel, and the lighting model is slightly better. So for the most part, you can literally just have the base color multiplied by 1 over pi, right? You don't actually need to do this, but if you want to get closer to how reality works, which is what physically based rendering is attempting to do, you do need to do more maths. I think this was discovered in 2012 as well. So these lighting models are used in Disney animation as well, by the way, as well. So but we're just using older versions because it's older versions of this lighting model, because the more advanced ones, especially the bidirectional surface scattering reflectance distribution model, the BSSRDF, right, which is a bigger version of the BRDF, right? It's like a bigger version, is too expensive really to deal with. So we just do with this. We use simpler versions. Hi Nilamation. Good to see you, my man. I hope you're having a great day down in Brazil. Early bird here. You're making a stream at 6 a.m. my guy. Yeah, it's I think it's it's 6 a.m. where you are. Hopefully you're having a good morning, whatever you end up doing, and a good breakfast. So yeah, any more questions? Yeah, feel free to ask me questions about lighting and stuff. It does help me actually learn this stuff. So if you are interested in learning about BRDF and lighting and stuff. I won't know all the answers yet, but I will as time goes on. So yeah, hopefully that clears stuff up. It's actually really, really interesting. I find it's like super fun learning all this stuff. So yeah, hopefully you can implement, if you're also coding game engine stuff, hopefully you can implement some physically accurate lighting in your engine too. Maybe that would be cool, or whatever you end up doing, because I know some people are also. Oh, you know, I haven't done. Sorry, I just realized. Let me grab my. I need to list the new notes I've added in my index. Let me just, because this is my. I didn't add these in, so excuse me just a moment. So this is my graphics theory. So geometric shadow and the mobile version, which is for mobile class GPUs, which is I would even imagine that this is not even needed nowadays because the GPUs in mobiles are getting better as well. But I don't know. It may be good to simplify some of your the G part of the BRDF for the specular geometric shadowing. Which, if you don't know what I'm talking about here, the shadowing is what we just talked about with the microfacets. So these are called microfacets, right? So it's simulating this effect. So it's without doing this, the reflectance of a surface would be too high, right? It would be like this or this basically all the time. But because of this, we can start to simulate some of the microfacets in surfaces based on the roughness value. So that's what that's for, and we have a simpler one for mobile, which doesn't do a bunch of square roots, which may be needed if you're interested in doing mobile. So Fennell is a very famous guy, and to finish off the specular side of the Fennell, of the specular side of the bidirectional reflectant distribution model, a distribution function, we need the Fennell factor, which finishes off our specular lighting. Okay, so let's dive into that. So yeah, this is I'm having a lot of fun learning this. So the specular Fennell. So this is the thing I don't understand. This is the thing I understand the least. So this is going to be interesting to learn. So specular F. Okay, let's read. The Fennell effect plays an important role in the appearance of physically based materials. This effect models the fact that the amount of light the viewer sees. And yeah, just in case anyone's just kind of confused at what I just said, if there's something you don't understand, that's my fault, right? So if you want to ask a question about something that I said and it's not clear, feel free to ask it in the chat, and I will clear up some of the things. Yeah. So just getting some water. Okay, so the Fennell effect plays an important role in the appearance of physically based lighting. This effect models the fact that the amount of light the viewer sees reflected from a surface depends on the view. Okay, so this depends on the viewer angle. This is all to do with the viewing angle of a surface. The large bodies of water are a perfect way to experience this phenomenon, as in Figure 10. When looking at the water straight down at normal incident, you can see through the water. However, when looking further out in the distance at a glazing angle, where perceived light rays are getting parallel to the surface, you get to see more specular reflections on the water. On the water become more intense. So you can see here that there's basically no reflection, but you can see like here there's tons of reflection, right? All these are reflected. So I'm going to throw that in here and go. You can see that the glazing, grazing, sorry, glazing angle of the light. You can see that the grazing, as the light rays get to a angle, the specular the more specular the surface gets. Okay. You can also see that it's basically not specular at all when up close. Nice. Okay, so the amount of reflectance, the amount of light reflected depends not only on the viewing angle but also on the index of refraction of the material. Okay, so you also need to have the index of refraction. Kind of bold this. IRE, no, IOR of the material. Normal at normal incidence, perpendicular to the surface at 0 degrees, the amount of so at flux by F0 can be derived from the incidence of reflection as well. See section 4.8.3. whatever. The amount of light reflected back at the grazing angle is noted at F90, which appears 100% for smooth materials. Okay, so our documentation here, in our note, when we are talking about the normal incident, when we are perpendicular to the surface, let's get some water. The amount of light reflected back is, which can be derived from the IOR as well. That the amount reflected back is FO0. So that's the incidence of reflection. I don't know if we have this in my material. I might have to spend a bit of time trying to get this out, because I have roughness, I have metallicness, so that's not the same. We have occlusion. I think it's incidence of reflection. So let's just take a minute to do a bit of research. Oops, I'm gonna look up my GLTF models and see incidence of reflection and see what's in it. So GLTF incidence. Oops. Incident of reflection, right? So, okay, that's not quite right, probably. Material specular KHR. And what is that for? That is for yeah, because if we don't have the data, then we can't do anything with it. Okay, so this is... Okay, yeah, so here's the finale function of if you wanted to implement it. So the problem is, though, we just do not have any models that have anything in it to do this, as far as I can see. So I don't know what to do when you don't have a model that's got any instance of reflection in. Let's what I can do is easily just open up a model in my code and just see what's in it. So we have two models. We have a duck, and now obviously we don't have many things in our game engine right now model wise, but let's look at what we do have and see if we do have instance of reflection, and then we can try and pull that out in our shader code so we can actually get somewhere, right? Alright, so we have a rock. So if you don't know, oh, this is GLB. Okay, so let's open this up in Blender just quickly and just see what's inside it. Where's Blender gone? Not Factorio. Yeah, let's not go down that rabbit hole. I'll lose a week of my life again on just playing Factorio non-stop. If we open that game once. Anyway, so import GLTF. So let's go into our model. So we have, okay, so we have build. Where did I put it? Assets, models. Yes, it's all kind of scruffy right now. All right, so what I'm interested in is the shading, I think, to see what we have here. So let it open up in Sketchfab. No, whatever this is. Doesn't it have any anything in here? Oh, there we go. That's all I want to see. So, oh, so it has some emission. Interesting. So it has. Scroll in. So it has occlusion. Right, okay, so what else do we got? We got the normal. Okay, so we have an IR level. So I'm kind of interested right now. If I so yeah, if I look at this, there is basically no reflectance on this at all. I don't know why it's not showing up like that in my engine, but Blender's lighting model is a bit weird. So we have roughness, metallic, yes, which is just green blue, which is fantastic. Base color, obviously, and so we do have some IR, I think. Oh, it's not connected. So our IR value is, so 0.5 means no adjustment. Okay, so 0.5 seems to be like just the basic then. Okay, so when we're doing this Fennel thing, how do I get in the the IR? I don't think I do actually, do I? Let's have a look at my code a bit more. So let's restart the music. Okay, so when I'm loading the model, and I want so we get out the material. So this is a material thing, so it shouldn't be too difficult to get out, even if it's just an extra thing. We just got to add it to the list of things that we need. Alright, so we have a material guy here, and what do we have? We have... Okay, so has I... Yeah, okay, so what is this? Yeah, it's just a float. Yeah, so we can probably get this in to our material, so we can actually do something with it, our instance of reflection. So I'm going to check it, it even has it. I think if it doesn't, then we just do 0.5 maybe. So I'm kind of curious if I throw this at the top here. So if I go if because I don't think we have this, has instance of reflection. If that's true, then just break here, right? Feels weird to be back in this code. I haven't been in here in ages. Alright. So do you have I has instance of reflection? No. Okay, so nothing has instance of reflection by the sounds of things. And so if I was to kind of pull this out anyway, what's the value? So instance of reflection. So I assume this is a float, right? Oh, it's not. It's whatever this is, which I believe is still a float. Yeah, if we have a look, it's a struct with 4 bytes in, which is a float. Yeah. Alright, so let's just see what this value is, and if it even has a value. Does it crash? 0. Interesting. Huh. Okay, so if you want to work out the Fennel instance of reflection, and we don't have instance reflection in the model, although it seems like it says it's got, in Blender, it says it's 5? 0.5? Yeah, tint. So if I was to make this pink, does that change? Ah, okay. So, and if I change this up to like 1, yeah, it gets really, it's really pink. But if I change it to 0, we shouldn't see any pink at all. Whoops. Color, get off, go away. What is happening? I want to change this. No. Let's put this at 0. Yes, we have no pink at all. So effectively, I think we're treating this as a... But if I put this back to white, what is the difference? So if I put this at 1... Ah, okay, so we have a instance of reflection, which is, and a 0.5. Okay, so it looks like to have the instance of reflection for models that don't exist, everything's kind of defaulted to 0.5. I think this is up to me then, as the programmer, to figure out like what I want. Obviously this is such a minor effect, right? But if it does have tint and stuff, I do need to handle it, I think. Because otherwise... What I might do is create a sphere, load it in as the ducks, and just for now test it with super aggressive instance of reflection. Like turn up the specular up to 1, because I think I could do that. So linear, flat. Yeah, so what I could do here is just no, let's look online actually. I need like a demo model. Spheres to test rendering. I don't know where I'd find these though. What is this? No. Three Earth models to test. Yeah, these things are something I'm interested in. What is going on here? No, I need the models themselves. No, stop it. I've seen them before. They're kind of like let me explain. The kind of like, if I go to further down here, right? This is what I want. I want like a sphere. I mean, I think I can just make it myself, but you know, I don't want to have to make every single one. So I'm trying to find like a sphere. Oh, common 3D. No. Models, spheres with materials on, kind of thing. Yeah, that's what I'm after. Material spheres, 3D fab. Is there more than one, or? Yeah, okay, so it's got roughness, it's got... Why is it upside down now? I don't know. I mean, I could get that, but... Is that what it's called? Material sphere? Is that a thing? No. Sorry, I know I'm taking a bit long on this and I kind of want to get through it, but... Free spheres for download. Okay. Because I can't imagine it's that like expensive, right? No. Okay, that didn't exist. Maybe this. No, that's gross. No, they're not quite understand. Google, or DuckDuckGo in this case, is not understanding what's going on, what I'm asking for. No. Okay, so... Because I just don't know how to do UV mapping at all, and I would have to like learn how to do that on the fly. Okay. What is this for? No, it's just a... Okay. Ah, there is a GLTF GitHub from Kronos, GLTF samples. Oh, really? Okay, that's really, really cool. Thank you. Let me Google that. That's exactly what I'm looking for. If I can find it. So GitHub Specula test and by Kronos. That looks correct. And yes, this is what I would need. To test my... So if I can grab the models. Yes, so it's got all this stuff in what I need. It's got these 0 and 90 for the instance of reflection. Okay, so renderer rendered by... This looks good. I just need to grab the... I want to make sure I get the right thing here, just rather than clicking around. If we go back up, here we go. Right, fantastic. Okay, so this is perfect. Hell yeah, this is exactly what I needed. Thank you. Can't touch this. Appreciate you, dude. That's saved me a bunch of time. Okay, so we want to download this. Can I download it? Fantastic. So let's just see. The first thing I need to do is open up in Blender and export it out as Blender. The reason is it's just to keep all my models consistent across the same exporter. Otherwise, I've noticed I run into weird issues if I just download them offline and try to immediately run them in the game engine. Oh, I have a breakpoint. Just close that for a minute. So we're just going to open up Blender again and import export. Yes, thank you for that. Can't touch this. That's very much appreciated. Just saved me a ton of time there. Alright, so let's get in here. Go to my downloads. Specular test. So we should see... Fantastic. I don't really mind. It looks like this. This is perfect because it's got all of them in. So if I go to shader, we should see hopefully all of them kind of correctly rendering. So we at least have an idea of what it should look like. Oh, come on. Ugh. I really don't know how to use the Blender camera. Yes, okay, that'll do. So specular texture, blah blah blah. Okay, it's got it all. Hello, Manuel. Good to see you, my man. How you doing? We're just dealing with getting a new model so we can test our engine a bit more, and then we can go back to working out the Fresnel index in our physically based approach to lighting, which is what the BRDF in the title is about, if you're interested. Okay, so let's obviously throw this in here as specular. So specular spheres. Okay, cool. So it looks like there's probably more I can grab later on as well. Right, cool. Give that a second. Now, I don't think I have this, what is it called? The extension supported yet. But this is why it's here, right? So, instead of a duck, I can render an extra object maybe. And leave the ducks alone. I don't really know. I'll decide that in a minute once I've got this open. Okay, so what we're interested in is when we create things. We do a second do another position. Let's do 4, 4, 4. It's not going to be very exciting, this. Oops, now I could just do 3. And in fact, let's take this and put this on 555. In the game, we're going to make this static. It's going to use the same duck shape. We're going to call it a duck, which is going to be wrong, but in fact, we need to do this. Duplicate, call this spec sphere. Yeah, because unfortunately we need now a whole new thing, which isn't the most adaptable, I'm aware. But that's fine. Because I don't want it to interact with anything else. So when we do this, we go in here and model type. Yeah, okay, so this is good. I think it should pretty much not break, but we'll see. I just need to make sure that once we've done this, we also load in the spec model, which is called specular spheres. GLB, absolutely make sure this is correct so we don't end up with a weird issue. And it's going to have the same layout, yes, that's fine, so it uses the same model. And according to my render loop logic, that shouldn't break. Let's see. What ECS framework are you using? I am using my own. I decided to simplify everything down by just hard coding the entities with their components. Making all of them public, no inheritance, and now I just loop through each entity, grab its index, and then that index is an index into a second array. So we have models in like a big array, and all I do is just carry the index over. Oops, can I just change something in the scene? I don't think I updated something. So that's what I've been doing. I know it's not everyone's cup of tea. I know people like to use ENT. And things like that, but you know, I feel like it's not overkill for me. It's just like I don't need it. Yeah, so it's these reduced by 1 because we've got 1 extra thing here. So yeah, that's about it when it comes to my my entity code. I'm just going to make sure my render loop makes sense for what we're trying to do here. Just to, yeah, so we have our. Yeah, I think this is going to work because we're still getting the amount of models, and we're just looping through the models, and then we're just doing an instance count based on that backwards. And I hope we still instance rendering. Let's see. Also, it's fun to learn stuff. Indeed, it is. Yeah, it's just for me, it's just overkill. That's all. That's my Windows noise. Apologies. To use like a full like threaded modeling ECS library, I don't need it as much as say other people. Scene. So, but I can totally understand if you're using like a heavier weight entity system. But yeah, thanks for your question, Emmanuel. Right. How many entities can the system support? Oh, as many as I want. But I have to hard code them in, so it's not as flexible as say something like a generic system that loops through the components and kind of brings them together, right? I don't have a system. I have components. I have entities. I just don't have the system. So without the system, I've got to basically take the components, stick them in a struct, and then if I want to access individual parts of those components, I go, okay, that component there is related to this array. That's an index 20. Go to there, get that value out, come back. Those indices are in the actual struct itself, the entity struct. So in theory, I could have, you know, 1,000 entities, you know, billion entities if I wanted to go crazy. That would obviously not work, but you know, because of RAM limiteds and stuff like that. But anyway, I'm not limited. The only downside of this is it's harder to do stuff like scripting now. It's harder to do stuff like to have things run in parallel when it comes to looping through their entities, because the components aren't generalized like a system would allow you to do. But I don't need that, because let's just say I have 7 entities in the whole game, because I want to make a simple game. Having a full ECS for like 7 things is kind of overkill in my opinion. But you know, other people would maybe disagree and do their own thing there. But that's how I work. So I've scaled it down to basically work on what I want to do. So let's just see if this loads. Right, so we might get an error here because I've never loaded this particular type of model before. And I haven't resized the models, so the array is too small. Yes, so we need 3 now. Let's do that again. All my arrays are they're not dynamic at runtime. Oh, I didn't have tangents. So this is something I always forget to do. Because of the lighting model I'm using, I need tangents to be exported. It's been such a long time since I've done things, so I didn't export with tangents just before, so that's why that didn't work. So this just simplifies everything in the shaders, and it just all it requires me to do is open up someone else's model and export with tangents. So it's really trivial to add. It just if you forget, you get that error telling you off. So import and then export. So tangents aren't included by default for some reason, and now we just need to go back to where we were. Void build. Where were we? Assets, models, out, specular guy, overwrite. Right. Doesn't that back and forth cause performance issues? Like you have to iterate through the array to find the model for any particular entity. No, it doesn't cause performance issues, but it can be slower if you don't. But I don't need that level of parallelism. Like I said, if I have 7 entities, like I don't have to worry about the speed at which they loop. Oh dear, we've got this. Like I don't need, if I have 7 things, we're gonna be getting performance in other ways. Everything's still contiguous in memory. There's no pointer in direction. The indexes themselves are just indexing into contiguous arrays of memory. So the looping through the arrays themselves are fast, but we're not doing them in parallel. So that's the thing that I'm missing, right? That's what an ECS allows you to do. I'm doing it in a sequence. So you can get, yes, it is technically less performant, but it's what I've got in return is a super simple version of an ECS. So let's run that. Did I not have tangent data? Excuse me? Why are you being... Did I not export it? Let me export it again. I don't know if it did. No, data. Yes, tangents. Can you export and say overwrite or something? Okay, so where did that export to? That's the other question. I'm probably exporting to some other wrong place. That would be a classic, right? Void assets. Build. No, that should be the folder I'm messing with. Okay, just for sanity, I'm just going to put 1 here and just... I know it's a bit of a... I just need to do a sanity check here, because this is... yeah, it's been a while since I've uploaded a new model, admittedly, to the engine, so... Bit rusty on this side of things. Yeah, it might depend on your planning to have. Yes, the problem is with people developing their own custom engine. This includes me. Think too far ahead and think they'll need someday and use ent. Yes, which we actually don't need it. Yeah, pretty much. That's my opinion on it. I used to be a bit of an ECS hater, so I kind of went the other way. But yes, I generally think for most game engines, that it depends on the game you're making, that you probably don't need ent. I was thinking about how it won't cause you're iterating. You're not iterating, just getting the base model index. I'm thinking about it now. It won't cause you're not iterating just to get the model base. No. There's like multiple indices that I'm pulling out for things. So it'll be model index and then like positional index, and then it'll be like whatever index I need as well, which will be part of the component system. Not component system, because there's no system. Part of the loop, I should just say. It's just a loop. The thing you do need to worry about, though, is stable IDs, which is kind of tricky to implement. So if you're going to go down this path, that's something to look into. Because if I delete something from all these arrays, like the index that which indexes into them, you've got to be careful how you deal with your arrays after you've removed something. Because let's just imagine that you shuffle all the things around in the array. Then yes, you can end up in a trickier situation. All right, so I call this 1. If this doesn't have tangent data, I'll be kind of confused, because it definitely does. Or it doesn't have tangents. Oh, I see. Okay, so I need to add tangents in, I think. It likely just doesn't have the tangent data at all. So how to add tangents to models. How to add tangent data. Tangent vectors, yeah. To models in Blender. All right. Okay, so I'm probably going to believe the AI here, because this is super basic stuff. So to add tangent vectors to models in Blender, you use the geometry node to extract tangent vectors from the UV map. Okay. Okay, so the tangent direction can be derived from a cylindrical projection of the XYZ from the UV mapping full control. A tangent direction vector. How do I add it though? I struggle with Blender. I really have, because I'm so behind with my coding, it feels like I don't really touch Blender, because I feel like there's like a billion things to learn when it comes to engine development, but then things like this happen and how do I select everything? This? Yes. So the UV editing maybe, and then like tangents. Is this going to be here somewhere? I just want to add tangents. I'm developing a multiplayer version of Tetris. I have ent in my engine. So stupid. Just a basic game to start with. Yeah, it's well, I wouldn't say it's stupid necessarily, but yeah, the analogy I like is that which has helped me think about what I need to implement, and I fell for this too. I added mesh shading to my engine, and I kind of increased the complexity of the engine just because I did that. Your engine is as complicated as the most complicated part, right? So let's just say you have a really simple engine. However, this is the most extreme example, right? You have the most convoluted, difficult to understand, really detailed entity component system. Even though everything else is simple, like everything rises to the complexity of the most complex part. So everything gets boosted up in complexity because it has to interact with that system, and everything has to go through it. And that could be the renderer, that can be the the gameplay code, the scripting, the whatever system, right? So keeping that complexity low for all things and thinking about what you need rather than what would be cool to implement or something like that, like I did with meshlets, is a good way to reduce the complexity of what you're doing. But that's just an opinion thing. I think that is helpful. It's a good mindset, in my opinion, to have, because I have fallen trapped to that with, like I said, mesh shading and other stuff. So, okay, so I need to really figure this out. Tangents. So this can be worked out. So I'm probably, unfortunately, going to have to pull up a video. Hello, I'm making an engine that will need to support hundreds of enemies on the screen, so at once. So I'm using flex. Sounds good. Yeah, well, that's good. You've thought about what you're doing, you thought about the game that needs to be done, and you've picked a piece of software that makes sense for you. So no, why did it do that? Unlock tangents from a point. Finally, perfect tangents. What? Can't you just... This might be... Oh, this is... I thought the assumption was a... Okay, so there's an extension. Unlock tangents. Tangent points. Unlock tangent points. No, I just need to figure out the tangent vectors, which are just orthogonal to the... They're literally just... orthogonal to the normals, right? Where the heck? Yeah, I'm trying to export with tangents, but the data doesn't seem to exist. So when I go export GLTF, so, and then I do tick this box with tangents in, it doesn't seem to have tangents in it when I export, for some reason. Because my engine will just completely just not work if you don't have tangents. And that is to reduce the complexity of working out tangents in the fragment shader, and it's the specular sphere one, right? So it looks like despite the fact that I'm exporting with tangents ticked, they don't exist, and because I can't. But it's something to do with the UV. I don't know. Check the material graph. I think the tangent node is inside the material editor. Oh, material. Okay. Material. Yes, like I said, I'm probably the biggest noob in the world when it comes to this. So materials, where would they be? Are they in the shading? No, this. Because this is the BRDF materials, right? Or is it this? Okay. Can I add tangents here? No. Your model should be UV unwrapped first. I think n-gons are a little funky. So your model should be on UV wrapped. So if I go to UV editing, so can I select it all, right? I know. So they're the labels. Okay, so that's everything, right? Oh, are these are the n-gons here? Let's see. How do I see the difference? Okay, so now we have these icospheres. By the looks of things, and everything else seems fine. The only thing is the origin point's a bit weird. But I don't think that matters because they're all relative to this sphere. Okay, so looks like they're good. There's no weirdness going on. It's actually all triangle based rather than quad based. Anyway, so UV on map. Whoops, I'm unsculpting. So UV editing, right? Yeah, just bear with me. I know it's like I said, I'm a bit of a noob. Actually, I'm the biggest noob when it comes to this. Because admittedly, I don't find modeling that fun. So, but it does suffer when I get to this point. Okay, there's UV. Okay, so unwrap, smart UV project. So there's 3 of these things. So let's look this up, right? So your model should be UV unwrapped first. Okay. Okay, and then what do we do? We I think import, right? Okay, so import, adding tangent vectors to UV mapping or something. I don't exactly know what to do. Okay, so the UV node. Okay, so where's this go? UV tangent node generates the direction vectors and a UV map. Okay, so the tangent vectors are, yes, unit vectors that lie along the surface of the geometry and point in all directions, increasing. Yep. That's what they are. So this UV tangent method. Okay, so uses the Minkowski space algorithm for tangent compilation. Produce a consistent you can't have tangent data if there's angons. Okay, so imports. Oh, it's in materials. So go to the shading tab. Ah, okay, right. Thank you. I didn't quite understand. So I'm going to go back then and kind of leave that there and go into the shading, and then in the materials, go to the shading tab, Shift A. So I assume that means, and then import tangent node, which is, okay, so there's tangent there. That's a good sign. And okay, so obviously this needs to be connected. And how do I do how do I do that? Radial, sorry, versus UV map. Okay, so let's have a look what happened. Oh, I didn't do it right, sorry. Let me delete this guy. So this needs to be for everything, right? Why is it? I see, so I thought I was selecting everything, to be honest. Okay, so it looks like, unfortunately, these are all individual models. So we might have to add tangent vectors to literally everything, all of them. Okay, this is kind of tricky. So Shift A, import, and so we have tangent, and I believe, okay, so that breaks it. No, okay, so it needs a, so do I need to unmap first and then, oh my goodness, this was not on the docket today, I tell you. I mean, we could fake tangent vectors. I'm going to try something just real quick and just see if I can throw in some junk values to this, you know. So if I go to this, Oh, no. Okay, so we need to... I didn't realize this would be this difficult without tangent vectors. What I'm going to try and do is just see if I can just upload some junk values. So let's just try and do that. I know it's not ideal, but so 0.f. We use tangents in the BR. The problem is we use it in the B. This is tricky because the lighting's not going to look correct because the BNT, the BTN matrix uses the tangent vectors. The only way I've been, we have to use partial derivatives to work out the tangent vectors. All right. Yeah, I just don't know how to generate them based on this model without. We need to do it on a UV map or something. I just don't know how. I feel like if we do the partial derivatives in the fragment shader, even if the lighting's a little bit wrong, we will get somewhere a bit faster. But each model has its own like. Oh. No? Okay. I was hoping it would do them all. And but it might be we might have to do this because sorry, we might have to I mean, this is good to learn. It's not like it's not like the end of the world learning this on the fly. But I don't know how to. So this is the UV. Can I UV unmap them or something? Man. Oops, my bad. You've unwrapped. So if you've unwrapped, I think you select all, then go to edit mode, right click on the face. Okay, so let's try that then. So I'm going to try to go to here. What is happening? Okay. So I'm going to the UV on map was apologies guys, I do wish I could do this a lot faster, but yeah, isn't that everything selected? I don't know how to select everything outside of just doing this drag, but we have a different color here, which is confusing me. Oh, tab, okay. Okay, thank you. I didn't realize. I didn't understand what you were saying before. Okay, so if you've unwrapped them, so unwrapped angle based. Okay, so we've unwrapped them. Then select all, go to edit mode. Where's edit mode then? No. And then go right click on the face. Oh, I'm in. You're in edit mode. Okay, so now right click on the triangle. Now right click on the triangulation. Sorry about. Thank you for helping me. By the way, I know this can be a little frustrating when something's bumbling around so much. So I appreciate you. Just right click now. Okay, like this. So that's a right click, right? Not left click. Then I need to go into face mode. You need to be in face mode. Okay, face mode. Face mode. Face. And then Insert face, no. How do I get in face? Are these different modes? UV, no. I wish it was a control F. Let me just fix the music real quick. Give ourselves a break for 5 seconds. Let's get off this track as well. Okay, cool. Press 3. 3. Oh. Something happened. Okay, so I press 3. I would like to know what to do next, but I don't really know what I want to do without. I feel like I'm about to break something if I touch something. We're in a super fragile state now. Now click A. So press A maybe? Oh, okay. And then like maybe is there a do tangent thing? Now right click. Oh, sorry, I didn't click on the right thing. So A, what do you mean this? That's left click, right? Oh, I see. Triangulate faces. Okay. And then they're already triangulated, are they? Beauty fixed. End gone. Did I do the wrong thing? Let me try that again. Triangulate. Oh, okay, that was terrible. At least I know the undo button. Is there a... Did I get the tangents from that? Or... Ah. I feel like this is what artists must feel like if they are programming. Screwed. Usually I would ask someone on the Discord, but I know it's not the most exciting thing. I'm sweating bullets trying to get this to work. That's what artists feel like, you know. Now export with tangents enabled and try your best if your engine doesn't work. There's a UV map issue. Okay, right. I will do that now. Fingers crossed. What I might do is export as GLTF and as well, so we can see that, you know, we can actually obviously let's see, what is this? Okay, so I was just checking that wasn't going to break anything, and then obviously export to GLB as well. So this is just to let's just make you know, we've got to be careful here. When I did GLTF, did I have the material? Where is it? Yeah, okay, so when I did GLTF, yes, we had tangents. Okay, fantastic. Let's see if I open up this in text. So specular spheres. So what I'm going to do is just open this up in the text editor and just look for tangents. Wait, double check if it's enabled. Yes. So we should have tangent. Yep. Alright, so we have tangents, it looks like. That's what I needed. Okay, so fingers crossed. Obviously I'm not going to use the GLTF version. So let's get rid of this. So please work. I'll put a breakpoint here so we don't get the sad error message at the very least. Come on. Oh. So the tangent accessor is still null, and that is for Yeah, still for this guy. Let's do a sanity check just real quick. What I'm going to do is just export in it again. And we have the tangent thing, but we're going to call it something else, right? We're going to call it a GLB. We've got to make sure that we've... Oops, no. This, thank you. And export. Okay, so that's a separate file now. And we're going to go back. Yeah, thank you for bearing with me, guys, and helping me out. I know it's like a little, you know, a little tricky when you just like, just click. No, I did the wrong thing. Kind of thing. So I appreciate you all, you know, bearing with me with that, with this so far. So, okay, that worked. Okay, we got it. It crashed for a different reason. Fantastic. Thanks, guys. Yes, the problem is there was no tangents at all, but we've added them in, I think. It just crashed for a different reason. So, yes, GLTF tangents are optional. So I have to have them in every single time. So yeah, we got a crash for a different reason. And it looks like we got a... okay, so we got a buffer over... Okay, so we got a out-of-bounds buffer read. And that's likely because we have a new model here and we got to deal with that. Yes. Okay, so what I've got there is I've got a buffer on a GPU and we've gone over bounds of that, which is good to know. So I just haven't done something which I need to figure out. One moment. Yeah, hooray. Yeah, thank you guys. Honestly, big up to you guys. That was all you. I can't take any credit for that. Yeah, thank you for helping. And now I'll have to memorize that method. Maybe watch myself back in off stream and write some notes so I don't have to do that again. Anyway, so we got a... and that was for the physical storage, but yes. What was it for, though? It was for the... reference. I mean, I could turn this off, but that would be bad. VK, yes, shader. Address, which one though? The physical store, yes. What? Which buffer was it? Was it the vertex buffer or what? Okay, so it was the instance index. So we have an instance index, yes. Okay, so yeah, it's just going to take me a minute to figure out. Okay, what buffer we're working with here and what went wrong, if it's both. Yes, I will write my notes in Obsidian, because that was a whole... So it looks like we have to unwrap and then say triangulate, and then for some reason that brings about the sorry, the tangent vectors. So I'll write that in what we did. I'm glad you're liking Obsidian, by the way. It is pretty good. One day you'll maybe it'll look like... I've seen this isn't a... You should see other people's Obsidians. Like this is relatively small compared to like what other people's look like. I've seen like hyper dense structures that just go on and on and on. Oh, you're using Notepad before? Oof, yes, that'll definitely be an upgrade. The connecting between notes is OP. Okay, so the spec, yep. Okay, I'm gonna just say what I'm gonna do then, because I can't exactly figure out this which buffer's the issue, and it's part of index draw call. So we need to. Also, is it possible to bring these all into one model? That's another thing I want to try. Because at the moment we've got this situation where everything's kind of separate and it's got its own transform. I would like to have its own transform, kind of. Actually, I'll do that later. That's separate from what we're doing. Anyway, so a buffer advice. Okay, so we have 64 bytes read at let's just see if it renders. Can I just be naughty here and just remove this error checking? So what I'm going to do is I just want to see if we actually get anything. Now, we might get junk, so I hope this doesn't flash. If I do this, I've disabled off the synchronization validation thingy. Yeah, okay, so that's what happens when you got a buffer over. Yeah, let's turn this off, it's flashing. Control J, yes, that would be nice. I didn't realize that would be that simple. Okay, so I'm going to go back to... so I assume I can just select everything. And then Control J. Does it need to be in a particular mode? Edit mode, maybe? Nope. Okay, so I've either done it or it was already done, right? So if I do yes, okay, so they're at least together. I prefer to join them all, but there we go. I think that's correct, right? Yes. Okay, that's what I wanted. Thank you, guys. Let's do that because that helps out with my engine, not having everything individual. So let's just make sure our tangent data is good. There we go. And let's bring this back in. I don't think it's going to fix the issue, but it's going to help us with what we're doing. Okay, so what I'm going to do as well is just turn off instance rendering for a minute. We're just going to have one of everything. So and that's for that too. So this is just to make sure that if it's the instance rendering, so yes, so we should get one. We should get 3 models on the screen. Okay, no, we still got the issue. But let's see, binding 1. What are we missing here? The Vulkan spec says each. No, okay. Let's go back. I think we. Yes, because we're using buffer device address. So we're using a buffer that has a buffer device address access type that allows us to index into these guys via a GL index draw called instance draw, a GL_ID. And that is why we can't just do that. Okay, so let's see the original error again. Okay, so right, so what? Give me a minute. What happened? Did we confused? I'm a bit confused there. What I'm doing... let me think. I think all I'm doing is not adding enough data into this positional buffer that I've got for everything. So where is that created? And if I go into my scene code, so we have 3 models now. We have another object here, which is fine. It just has a position at 555. Okay, so these positions are different, which is probably not good. So let's make another position. This won't fix it, I think, but this is a start. This is a mistake. So let's just be careful here and just use position 4. I know this is clumsy, but I need to make sure that at the very least we are putting the data in the buffer, and I think we're not. And so we're trying to index over something that doesn't have any entry in it. Because if I was to make this a dock, right? So let's test this, right? Okay, so we've done that. No, I'm not going to test that actually. I'm just going to go through it very carefully. So we have entity type. So that comes through here as model type, yes. So I'm going to go into my render loop and just kind of figure out, work backwards as well. So I don't see any problems there. So I'm going to go back into my render loop, which is not GPU driven. So you have to forgive me for that. I'm going to head out now. Good luck with the Blender and your engine. Have the great rest of your day, everyone. Thank you, my Ben says, and thank you for helping me out so much earlier. So yeah, have a good rest of the day to you too. Whatever you end up doing. All right, see you around, man. Okay, so what I want to do is, when does this go wrong? So I don't think it goes wrong in the first frame, but I'm kind of curious. Where does it start to go wrong? Okay, so if I press F10, yeah, okay, it's fine. And I think it's the second frame, right? Because we tried to read further into the buffer. Nope. So we come back around. We're on frame 0 again. No, it's good. Okay. And frame 1. Now we could have internal synchronization here that's actually keeping things together, but I doubt it. So I'm waiting for a crash. Nope. Okay. So, okay. Frame 5. I'm just going to press 6, 7, 8, 9. Oh, I'm being dumb. Sorry, I just realized. I want to do this. This is different. I was just going through a for loop there. So model size is, this should be 3. A model index based on that. So we have a 3 minus 1. Hang on. So, 0, 1, 2, yeah. Okay, so that makes sense. So when we're on, when this is on 2, that's what I actually want. That's what I actually care about. Let's do a conditional variable. So when this is equal to 2, which is the new model that we've added. So we skip a bunch of stuff. So what do we get out here? So if I press F10 or step over this, where's F10? There it is. So we have count, we have an index offset of 0, we have 0 flags. Okay, so it doesn't have any roughness, textures, occlusion, or emission. We have a diffuse texture of 9, so the textures did go. So it looks like everything's being uploaded fine. We have an alpha cutoff, 0.5. We don't have any specular stuff in here yet, which is why I wanted this model. We don't have any scale. We have a basic. I assume that's pretty default. We have the base color of 1, which is nice. So everything's kind of basic here, right? So we write that data in, and we access the vertex buffer. Let's have a look at it. Let's see. So the address is that, which is fine. So it has a buffer of 13. I think this is good. So then we push the push constants up. We have an index buffer 11. The offset should be 0. Yeah, and the component time should be 1632. Fine. Sounds good. Sounds good. Everything's good here. Now, what is this? It's not telling me. So model, and you go to data, and no, that's not the right one. I want to know this one at 2. Actually, no, this is is this going to tell me what it is based on... Let's look. Okay, so the instance count is... No, that would be all the rocks. That would be the rocks. Yeah, okay, so that would be all the rocks, that one, because the instant count should be 1 for what we're trying to do here. So we don't actually see what this is. Oh, interesting. What? Oh, really? The rocks is number 3? Sorry, I'm a bit confused here. So when I look at my data here, I'm trying to figure out what mesh we're actually on. And it doesn't seem to be what I thought it was, which is interesting. Because the conditional variable is 2. And if I go into this... Sorry, the model type, which is just an integer. If I go into my structs, which store the data in, where's my structs? They're not here. No. Yeah, I haven't quite finished my entity model setup yet, so admittedly they're not ideal right now. This is not used. I thought I needed it, but I hadn't. Okay, so utils? Here we are. Okay, so no, it should always be number 3 for the entity type. Which is confusing. Okay. Let's go into our... Okay, so what I'm confused with here is what buffer is causing the issue, like I said earlier. But as far as I can tell, if it's static, it doesn't do anything. It doesn't update the position at all. So I'm starting to think it's not this one. I think I can rule this one out. In fact, let's rule this out pretty straightforwardly, right? If I just remove the us uploading data to both the debug geometry and the main scene, we should see that either the same error happens or it's this. This will convert down. So I don't think it's the vertex buffer. At the very least, I think the vertex buffer is safe. Because it would have gone wrong in a different place. The model looks like a well-behaved model. Now we've got tangents in. So I'm going to say the vertex buffer is completely fine, that we pulled from the geometry. The positional buffer can be disabled pretty straightforwardly when we update that. But the thing that we go over for the actual instance, the instance buffer, I think that's going to be the issue. So if we run into that... Oops, I need to... Hang on. I just realized I haven't disabled the copy up on the positional buffers. Okay, there we go. Is there no way to check which buffer there is? There is by name, but it's not popping up, which is annoying. We might name it in a minute. Yeah, okay, so that's told me pretty much immediately what it is. Because there's 3 of them. This can only happen, by the way, by a buffer that we're trying to access via an index. And the only 3 buffers I have in my shaders, I'll show you, are so if I go to my standard vertex shader, which everyone's familiar with, hopefully, we have 3 different buffers, right? A vertex piece of vertex data, which is used to just get the geometry out, the tangents, normals, texture coordinates, and stuff like that. And then we have the other one, which is the positional buffer. And the positional buffer, I think... So the positional buffer... Sorry, let me say this again. The positional buffer's updating code is not causing any issues. But I think when we instance index, so I was a little bit wrong earlier, over that positional buffer, I think this code is wrong. So if I... Let's check that, right? So it's an easy way to check this. Now, all I'm going to do is just remove a bunch of code. I'm going to remove this. Now, this might cause everything to lag when you do this. So if we just do not use these things at all in our shaders, and in the debug shaders too, I've got to do the same. So if I go like this, and I go, so vec3, 1.1.1. Okay, so that's that done, because that needs to be passed over. And I'm going to get rid of these two. So everything's just going to be in the wrong place. So our instance index. So we're not going to use instance index anymore. Yes, I have heard of RenderDoc, but I can see at this point that it's a buffer device overflow. Sorry, a buffer out of bound read. We might throw this into RenderDoc later, but I kind of see a little bit more what's going on. Oh, this needs to be a vec4, I assume, right? And this is now a vec4. Ignore all the squiggly under red underlines. My extension in Visual Studios does not understand buffer device address access patterns for a buffer. So we get a bunch of like undefined things which are valid. So yeah, okay. So oh, hang on, this is not work. Okay, yeah. So I believe we can't move. Let's just make sure the camera is good. Yeah, okay, so everything's like, we got like 14 frames per second. No, like 10 frames per second, because it hates it when you do this. But as you can see, we're not crashing. And the engine is still responsive, despite it being really slow. This is because everything's drawn on top of itself, and I think we get all sorts of GPU issues when we do that. Okay, so it's the instance count thing that we're doing. Either the positional data does not have the data in from the new model, or the way we're handling the way we're trying to iterate over things is causing issues. So let's just compile them, and we'll go back to our scene. But yes, RenderDoc's always a good thing to use, so we might end up using that at some point. And now we need to figure out what we're missing. So this is a good practice actually for stuff. I was hoping to do lighting today, but I guess we're on this, which is fine. We'll do this for a couple of hours and then we'll go back. So yes, I'm going to stream for another 5 hours. So if it takes 5 hours, it takes 5 hours. Unless something comes up or the internet goes down or something. Right, okay, so... Okay, so... what I want to see is something normal. So I should see the ducks, which are the first three things, are 3 for this instance count. Then 4,440, and then 1. Right, so that should be the order of output. So what I'm going to do is, for the first, just to check if this is actually working correctly, I'm going to print out these values, or at least get a breakpoint on them, just to see what the instance count actually is. And what we're going to do then, so I don't think it matters too much, but we're just going to put a breakpoint in. Okay, so comma, and okay, so which is %d instance count. So let's just put a breakpoint after that. Printf debugging. I think what I might do after is maybe throw this into RenderDoc, I think. I've got more and more convinced that it's probably a good idea. So instance count 1 with model 10. Oh, I see. So we're going first. We're going in reverse order. So it's actually reversed. So it's this one, this one, this one. So hopefully we get out of this and we get instance count 1 again. What's this called? 2. Okay. Instance count 1, instance count 1, instance count 1. What is happening? Why aren't we getting out of this loop? What is the size of this? Hang on. 5. What is happening? Okay, something's gone weird here. Oh! Of course. We're drawing the individual spheres. Right. Yeah, there's more than one model type to draw. That's okay, that makes sense. Yes, okay, so stuff's going on here. Right, okay, idiot. Yeah, I realized that we've got an inner for loop that actually is meant to handle the situation when we have. Ah, okay, so this is going wrong. Right, okay, so so this is actually I think I figured out one of my mistakes. So we've got this should only be incremented when we're outside of the for loop, like this, because we have submodels in here, and if we look at our blender, right, these individual spheres are submodels, despite them being joined together. They have different materials, so they need to be drawn differently. Now I'm adding the offset into the index as I keep going, right? And I think this gets too large because we end up adding. I don't know how many this would be. So like what 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. So 35 plus 1, 2, 3, 4, 5, 6, 7. So that would be what, 42. So we have 42 extra. Well, 41. 41 extra because minus 1 for the actual relevant one. So I think we're overwriting this offset value here. 41 extra ahead, right? That's what I think what's happening there. I think that's my mistake because I haven't had a model with submodels in yet. That's why this is breaking. Because I haven't tested this specific type of thing. Model type index is not the same variable. Oh yeah, it's debug model. And instant. Oh, okay, no, that would be true for this. This would always be the case because we never have submodels for debug geometry. That's never ever going to happen. Okay, so let's just see if we don't override now with our instance count. There we go. That was it. Oh, nope. We were getting there, and now we have a different issue. So index 65535 index descriptor for what? Are we running out of textures or something? So this is the fragment shader, right? This is binding 1. This is an index. Okay, so index of. We might have run out of textures, maybe. So that was fine. As soon as I started to look at the I think if I do that again, right? Let's just see, because I just moved the camera and it broke, right? So if I scroll around, yeah, everything's good, blah blah blah. But as soon as I look at the model, we get like a Slender Man type situation where we get killed immediately, and yes, so something is gone wrong with this. So for each array, so for each array of resources that is used by a bound shader, the index used by the access member. Yes, 100%. That's exactly what's happened here. I think if I look at my model, so we're getting something in here that's telling us that our texture ID. Oh, hang on. I think this is quite straightforward to fix. I'm accessing something with index 0 in my bindless textures. So if I go into my fragment shader, which I believe is this one. Oh, we're doing this twice. That's not good. Why are we doing this twice? We're getting the same texture twice here. This is bad. And we get base color and fragment color. Okay, so yeah, this should be commented out, I think. This is for testing things without lighting. Okay, that's the first thing we need to fix. The next is to figure out, I assumed this would be guarding against an invalid access. Yes, you're right there. Can't touch this. I think what we're doing here is we're accessing a shader index by its invalid index. Let's just check this is correct. So we do have a define in here that tells us that we shouldn't be doing this. And what I'm going to do is just disable everything, right? So at the very least, we'll be able to see this thing, right? What I mean by that is we're going to turn off the lighting. And that means we're just going to use the base color texture. So we're just going to uncomment this. Oh, okay. Doesn't want to do it that way. So this is just getting the base color text with this. The downside of this is this still might be an issue. Have you tried the slang language? Yes, I have. Only briefly though. Oops, I need to return. I need to. Let me just grab this. I've heard it's really good. It's really nice to. It's closer to HLSL from my experience. But that's without me knowing much about HLSL, to be honest. So I could be wrong there. Okay, so why is this V color? V color is undefined, yes. Oh, I've messed up the capitals. No. Okay, so let me cut this out. And then just kind of Control Z. Yeah, okay. I messed up the capitals there. I think I pressed Control U. Cool. Okay, so that should, if we just return the base color. Well, no frag color. No, that should be fine. I don't need this. So I tried it, right, just to fill in the story of the slang, and I just kind of went, well, it was nice, but I don't really see the difference. Okay, so there's no, oh no, it's still doing that. Interesting. So it looks like there is some, okay. So I haven't handled the case, right, where you haven't given me a texture for base color. What I'm thinking here is some of the models, some of the submodels do not have any textures to them, and then I'm accessing by them invalid. Okay, so let's add a safety check in here. So that's actually really helpful that we found that out. So this is a unorm an unsigned int vector, right? So we can do the same safety check. So what I'm going to do here is if this is equal to invalid texture. I did this because I thought, well, who's going to give me a model with no textures? And I guess I just answered my own question here. I am. So else, again, this isn't perfect yet, but what I'm going to do is just set fragment color to vec for 0.5, 0.5, 0.5, and 0.5. Oh, and 1, because this is a alpha channel, right? So we're just gonna like gray, mid gray, because there's no colors at all. And I don't know which sphere that will be, but I think one of the spheres doesn't have a color in it. Sorry, it doesn't have any textures. So looking good. Where is this model? Oh, it's here. Okay, there we go. Ta-da! We were able to render. Ignore the debug geometry. I can turn that off. So that's with no lighting. Fantastic. And great. Let me just restart the music. Fantastic. I'm made up with this, actually. We made a good amount of progress already. Solved 2 issues in my shader / 1 issue in my rendering code and 1 issue in my shader. Fantastic. So let's uncomment this, bring back the lighting, and bring back that safety check. Okay, so this also needs to be here for this. So we need to do the same thing. Yes, thank you for the help, Cantoches. You actually, I think I have to give you credit on that one. You pointed out something I was missing. And thank you for anyone who's helped throughout the stream as well. It's always very much appreciated. It's actually one of the coolest things about streaming is that people just decide to come in throughout the day and just help me out, which is nice. So yes, I think I can do that. Then maybe, oops, not 0. I meant to say it the other way around. 0, 5, and then at the very least, we can do a .alpha here and just say alpha is equal to 0.1, and that will stop. That will at least get rid of the if statement, right? With the base color. So let's rerun that. And we should see lighting again without instant crash. Oops. Sorry, my mouse has gone a bit weird. Turn around. Okay, that's good. So, oh my goodness. Sorry. What is my mouse doing? Okay, so the reason that this isn't working is because we don't have any of the specular setup, which is the whole point. Let's get rid of the debug geometry. So now we can at least, when we start implementing... Oh, interesting. Why have you gone grey? Okay, that's wrong. That's good to check. Okay, so... base color equals... Oh, duh. I'm just reassigning a value. Okay, so that should not... That duck shouldn't be grey anymore. So we have... Let's go on this side. Turn off the debug geometry. Okay, yeah, so we at least have a... Okay, so the textures are now coming through. The albedo. Ooh, okay, where's the thing gone? That's actually kind of useful. We might want to put the directional light in a different way, maybe. So we don't have any of the specular setup. This is why it's all black, I think. Because there's no textures here. As far as I can tell. We have a huge duck for some reason. That's a lot bigger than it used to be for some reason. But we'll worry about that later. Cool. Are you shadowing the base colors? Are you shadowing the base colors in the if? Yes, I was shadowing. Yes, thank you. You caught that. Right, I'm just gonna head to the loo real quick. And after that, we'll keep on attacking this. So I'm just gonna put up a BRB in the classic professional streamer software of Windows 10. Say all professional streamers have this. All of them, I tell you. So yeah, I'm just gonna head to the loo, and I'll be right back, guys. Yep. Alright, see ya. Hello, back again. So yeah, the reason I wanted this model to be loaded, let's just do a bit of a recap. Like, why are we doing this? What's going on? So people might not have been present for the original. So I have been going through the. Oh, I didn't pause. Never mind. Filament, which is a renderer for Android, and as soon as I got to this, I don't have instance of reflection. So I couldn't even bother. I couldn't check if I've got this correct. Yes, I could just copy and paste the source code, but the whole point at this point in time is to really dig into this and understand the actual maths, so I can correct mistakes. So because of that, I had to find a way to actually check the specularity of models when it came to, which is just the reflectance value, when it comes to this engine. Because right now I have asteroids which are barely reflective at all, as you can probably tell. So now, if I turn this on again so I can see where I was. So now we have this, which is just a debug geometry, to check our specular values. And as you can see, either the lighting is not allowing this to be lit, or the specular values are bad. We haven't actually finished. We need a way to get the instance of reflection out on these specular spheres. For some reason, there is no. Interestingly enough, there should be text on here in textures. So I'm starting to think, despite what we've done, these models don't have, because these are labels. I think we've not uploaded the models. Sorry, the textures, or if we have, we've. I don't know. I feel like something's wrong with this. Yes, I don't know. I just have a sneaking suspicion something's gone wrong. It's also very small. Because even if I don't have the specular reflection, I think I should have text here. Maybe the text on the other side. And it's just... Yeah, okay, so there's no way of checking. Let's... so I have a really hacky directional light, as you can probably tell by looking at the... all the directions on these objects are different. So what I'm going to try and do is just mess around with that vector and see how that affects this rather than anything else, because it's more important that I get this at least somewhat working, so we can go from there, right? So I have a really hacky don't do this, guys. I literally have a raw lighting direction that's in here. It's not accounting for rotated models or anything like that. It's here deliberately for the purpose of just being the quickest and easiest thing to do, which I kind of wrote yesterday. So I'm just going to change some of the values and stuff like that. So let's just see how that affects what we've got. Okay, so now it's not lit at all, which is interesting. Okay, so let's try -1, I guess. Yeah, let's see. So what I'm kind of trying to do is just light it up in a way that actually can see something. Nope. So it maybe needs to be away from here, like I'll try -1 in the Z direction. Okay, so we have that, but I think maybe we would need a bigger value, like 10. I don't know. Okay, so it seems to be fine still. Same thing. I think it just gets normalized. That's why I was just doing ones. So if I do positive, because I'm not sure if the texture's on one side of that, you know, thing. So hopefully it's lit from the other side. And yes, okay. I have it. Yeah. I don't think this, you get rid of this debug geometry. So you see, I don't think this has any textures. So it doesn't really matter. Okay, so this doesn't have rough. I thought it had albedo textures though. That's the thing. Let me look at the shader. Right, so that's what we should. But what we should be seeing at the very least is if I go in here, right. Let me move this down. Is there a way to... No. Unless... I might have deleted them, maybe, by accident. Oh, they don't exist now. Interesting. Okay, so they don't have textures. Okay, that's... Okay, so if I'm not handling specular properly... And these are all just black, and they don't have any textures on. That makes sense. For some reason, all the textures have disappeared from here. So, okay, that makes sense. Okay. Right. Good to know. Good to know. Because if I do this is the only reason I did this. Okay, so everything's normal, actually. Nothing to worry about. The black spheres are just black because there's nothing in them apart from this specular thing. Right. Okay, so if I'm going to go to my materials, the vertices, I'm going to go above, actually. Let's get rid of this breakpoint. And what I'm interested in is to see if any of these have actually got the instance of reflection, which was the whole point of doing this. So I pray that this actually is coming through. So the whole point of doing this was to check this particular thing. Has instance of reflection. So I just need something to break in here. I don't really care what it is. Because there should hopefully be something in here. It might not happen immediately. It should happen once. Come on, come on, come on. No. Okay, so... so we're still not handling these correctly, but what is in this material? Then... So what I want to do is figure out... based on the model we've loaded in... It's possible I'm just not loading something in, you see. This is good to know. Because, yes, I haven't handled every material. But I've handled the common ones. So, what have we got then? As transmission. So it should, we handle this, we handle this. We basically don't handle anything else. Okay. Has specular, right? Let's just see if this is the thing we need to worry about. Is this what's in here? Yay, it has something. Okay. Let's just make sure I'm not... Right, okay, so these spheres are specular, not instance of reflection spheres. Okay, why would you need an instance of reflection for... Your objects are opaque. I think you're missing roughness values loaded by the loaded from GLTF. I'm trying to... I want to just test, that's all. I just want to test instance of reflection. Okay, so these have specular. So that's what this is for. So let's go into here. What's in specular then? So specular color, specular factor, and specular texture. Fantastic. Okay. What should I do with these then? So if we have specular... So we have metallic, we have roughness. We don't have glossiness, we don't have clear coats, but we do... The thing is, I don't exactly know yet what specular needs to be. In a BRDF type calculation, is this the... I think this is outside this BRDF, isn't it? This is the... If I look at the rendering equation again, which would be in the lighting theory. Where's lighting theory gone? If I look at the light transport equation, I think I've got this mixed up, right? I thought specular is going to be inside the BRDF, but I think the specular is this, the instance specular function, right? Yeah, the light instance. Yeah, I think this is... Sorry, reflectance. All right, instance, light instance radiance. Light instance radiance. Is that instance? That's not instance, is it? So I think what I've got here is... I haven't, in my lighting model... There we go. Got anything to do with this reflectance factor when it comes to like mirror surfaces. And... There we go. Light instance radiance function. So I think this is this part of the rendering equation. Which would require me learning a bit more about how to handle that. Okay, right. Good to know, good to know, good to know. Okay, okay, I'm learning a lot very quickly, but I'm also like, oh, this is not what I wanted at all. Right, so let's go back to the GLTF models, right? So, oh, this is just, so we have clear coat in here. Oh, do I have these? I might already have these. I didn't realize it was those models. Ah, okay. So, do we have instance of reflection in here? Okay, let's look in this, actually. Or at least something that does something like that. Interpolate, irridance. Yeah, so that is going to be outside of the BRDF, which we don't currently handle in my lighting model. Admittedly, it's not very good, though, so we need to improve it. That's the whole point. So what I'm looking for is just anything that mentions reflectance. Let's go to the top. If not, we'll just kind of roll with it and just kind of learn this stuff and then shove it in. But this is really good to know about the specular, like how to load in specular and what specular is when it comes to... I'm still going to keep this around because that's going to be useful later on when we actually have to handle mirror surfaces. Or mirror-like surfaces, at least. Yeah. Because what I'm doing at the moment, by the way, is just so people are wondering, like, what am I talking about? I'm kind of like writing my BRDF / rendering equation model again. Like this is why we've got a new shader here, right? So I've removed everything out. I'm slowly building it back up with better understanding of what's going on, because what's happened in the past is I've kind of just like written a thing from a website and just kind of left it there, and that has led to not consistent issues, but like the lighting model is just not good enough for the thing I'm trying to make at the moment. And so that's why we have like a really terrible direction lighting kind of system going on. Okay, so this is going to be useful for in the future, I think. But at the same time, we've solved an issue. We've solved two issues with our engine, which is great. Because everything is instant rendered right now, including if you have it once. So it's kind of like we need to anticipate how far we go down the positional data, which is what we're instant rendering over. So let's put these back. Let's just make sure this is good. It shouldn't be bad, because it was more we were overriding what we were doing. Right, so I'm just gonna run this just to make sure it's good, and we'll fix any issues that it comes about. Yes, we have that. That's not an issue. We're just not handling it. Yes, okay, so nothing's gone wrong. Except we can't see the... Where's the model gone? Is it... Oh, it's just gone over the top of the dock. Because we've actually updated the position. So we're probably going to put the dock in a different place. Because this is extremely small relative to everything else. For now, that's fine. So we don't have specular set up in our shader, which you probably do. You guys are probably pretty advanced when it comes to this kind of stuff if you're checking out stream. But yeah, let's go back to what I was doing ages ago, which feels like a couple of hours ago now. So we were here in just like kind of building up the model slowly. We don't have anything with instance of refraction. I still need to solve that problem. So let's try and find a... I'm going to look for a model real quick. If it's not in here... Antiquated camera. So what would have this in it, do you think? So we had specular spheres, right, in here? Specular test, yes. So, let's see, sorry, that's my Windows noise. Roughness, metal roughness sphere. With no textures. Okay. Right, okay, so what does this use? So this has a mission, I think. Oh, no, it has this light thing. Extension. Okay, so let's just go through some of the ones that kind of look good, and then we'll figure it out from there. So... I won't spend too long on this. If it just doesn't... If there's nothing here, then we'll just skip it. And we'll just worry about it a different day. Let's see, what's this? Okay, it's just a good model. What's this? Boombox. Okay. Camera. Okay, so that has camera data in it. Not that interesting for us. So we have clear code stuff in here, which is good. Damaged helmets, directional lights. All right. I don't think we need to worry about this too much. I just wish I had something I had the data for. Okay, so let's actually pull out the data of this model. Let's assume it exists, and let's try and get the data out, right? So we need this, and when it has this, then it has this, and it has a float value. Is that it? So that, I believe, is our... Let's see, if I go into filament again. No, I can go to my notes, actually. I've wrote this down. So this is incidence reflection. We say that the amount reflected back... Oh, I hadn't finished. Okay, so I believe, as far as I can tell, this is F0. It's the thing we pass in. So we need a way to pass this in, if it exists. Otherwise, I think we need a 0.5 set, because that seems to be the basic, right? So if I load in this model, and it has this, then so in this mesh draw, which is all the materials for each material, the textures, we need this. So I'm going to be careful here to say float IOR factor. That should be... I'm using scalar block layout. This is my only thing that's got standard bindings as well. So let's throw this into our shader. So I'm just going to assume this exists and then do 0.5. Which should lighten everything up at least. So when I go into here, we need the... Yes, we need this to be float. This is the reflection factor. So I'm just going to grab this and go into... Where have I put this particular shader? This thing, sorry. I think it's in here. Nope. Okay. Where is this? Where's the CPU side one? Yeah, so upload. So that's the one I've changed, right? No, that's the one I want. And this now has a very simple mesh. I'm going to change the song after this. Take this out. So IER factor is equal to mesh draw. Okay, so now if I go to my shaders, we should make sure this exists everywhere. Actually, we need this. Right. Okay, so I'm going to leave that alone for now. So we have a 2D shader. Okay, that has nothing in it. Just make sure this doesn't exist anywhere else that I don't want it. I don't think it does, but I'm just going to be careful. Nope. Yeah, I don't think anything else uses this particular... let's just do a control F find, right? Okay, so... Oh, core shader... No, it's using the core shader as well. I don't want to cause any weird issues. Okay, cool. So we should be able to access that now. Oh, there's another one. Yeah, I'll add it here. Okay, so when we are loading this material in, we say that Okay, so this was a lot more complicated than I let on, but we are finally about to finish this setup. Okay, go into the shaders and at the new fragment shader. Apologies, and nope, load GLTF. Ugh, I'm all over the place, scatterbrained like. Okay, so we need has this, and then we need to get the value out. Where's the mesh draw thingy? So not alpha cutoff, but IER factor, which is equal to whatever this material is. IER okay, so because it's literally just a float, I don't want to make it more complicated than it needs to be. Fantastic, and go in here. Yep, okay, it's definitely a float. And outside of that, we're going to set this to 0.5, which seems to be the default for most things in Blender, so we'll go with that. If you don't set this value in Blender, it assumes 0.5. Cool. And I think that's going to just compile without any issue. We shall see. We could get like a corruption when it comes to if I've messed something up with the layout or whatever. Okay, looks good. Nothing's weird. It's funny how small this thing is. Yep. Okay, that's still normal. We'll worry about that specular list stuff later. Fantastic. Okay. One step forward. We now have IR thingamajiggy, which now we can calculate in the Fresnel in the Fresnel's specular part of our renderer. Yay! Okay, so I'm going to change the music because this is 20 minutes long and it goes on a bit long. So I'll go through these up to there. And then we'll randomize it again. Right, okay. Okay, so instance of reflection is dealt with. Now we need to be able to understand it. So now we need to go back to the note-taking part of the stream. Which, there we go. I didn't expect to solve so many issues when I'm supposed to be studying. But there we go. Let's close some of these so it's easier to do stuff with. Okay. I love this song. It's like one of my favorite, like... it feels super important, like whatever you're doing when you listen to this song. Anyway, we say that okay, so let's read this again from the top. Okay, this is all to do with the viewing angle and instance of reflection, which is the whole point of what we were doing earlier. But at least now we have a default value and we've got specular working. Specular models in the game engine, but not yet working. We can do this with light ray. You can see this with the light rays glazing the angle to the steeper the angles get, the steeper the angles get, the more specular. No, I say reflect. Yeah, specular is fine. the surface gets. This image shows that the further away you get, the more the shows that the angle, the steeper the viewing angle, the more reflective the water gets. Fantastic. Is there any specific reason for using Vulkan instead of DirectX other than cross-platform? That is a big one, by the way, the cross-platform. But other than cross-platform, I think when I started to learn Vulkan, I already knew OpenGL, but I knew no DirectX. So I was like, okay, it's made by the same people. It felt like a OpenGL, when I was learning this at the beginning, it felt like an OpenGL 2, if that makes sense. Like the sequel to OpenGL, because it's made and supported by the same people. And this music has decided to stop on us. Very nice. So yeah, that was generally the reason, honestly. It was mostly, one, it's cross-platform, and two, I already knew OpenGL a bit, so I was like, alright, let's just continue, I guess. So that was, they were my motivations. There isn't any, I believe there is no, if you're interested in, you probably already know this, but I'm kind of loving DirectX after using VK for 3 or 4 years. Highly suggest it if you ever want to support the PS5 in the future. Interesting. I know some of the Switch's different APIs, but I didn't realize that the PS5 has DirectX on it. So it doesn't support Vulkan, if you don't mind me asking. I actually don't know that. We say that the amount reflected back is 0. AGC PS5 is literally have the same conventions plus usage. Oh, I see. Right. I was surprised then. Yeah, I was like, wait, I thought PS5 had its own thing. Okay, that makes sense. Okay, so it has like I assume it has like descriptor heaps and all kind of thing. That like DirectX 12 has been like having and all that kind of like same setup kind of stuff. That's really interesting. Yeah, basically, I have no good reason to use Vulkan over DirectX. The fact that it's the only reason I do that is because I want to support Linux. That's the only good reason, honestly. I don't really have a good reason apart from I was learning OpenGL once and I decided to then do the next one in the list. Okay, so we say that the amount are reflected back is 0, can be derived from the incidence of reflection as well. Okay, cool. Yeah, exactly. The command list set render targets, and the PS5 has set render. Oh, interesting. There we go. Okay, but in Vulkan, it is a bit different. You need to go with dynamic rendering. I see. Okay, so it's like yeah, that makes sense. Yeah. Okay. That's thanks for sharing that. Actually, that's really cool information. I'll have to keep that in mind. Yeah, that's there's so many things to learn when it comes to graphics. It's really fun, but it's also like pretty overwhelming. We'll get there, though. We'll get there. Just got to keep on keeping on. You know, the amount of light reflected back by glazing angle is noted by. Okay, so the amount of light reflected back by a grazing angle, or glazing angle, grazing angle is F_90. There we go. Which approaches 100% on smooth surfaces. Okay, nice. It's materials even. Cool. More formally, the Fresnel term. So right now we're just kind of going through the basics of lighting. I'm rewriting my my whole lighting algorithms because they're kind of poop. So, but to do that properly, I need to really understand what I'm doing. So I decided to take it a bit slower than I typically do. So that's why I'm hence reading these things and taking notes at the same time. Only then to code. Anyway, more formally, the Fresnel term defines how light reflected back and refracted at the interface between two different mediums, or the ratio of reflected and transmitted light energy. Okay, so more formally, the Fresnel term defines how light reflects and refracts at a surface between two different medium. Okay. So the Fresnel is interested in how light reflects and refracts at interactions between two surfaces, different medias, at the interface between two different mediums. Okay, that's fine. I think oops, my bad. Let's get rid of this as well, because there we go. That's better. Okay, so reflected back describes the inexpensive approximation of the Fresnel term and for the Cook-Torrance specular BRDF. Okay, so it also is concerned with the ratio of reflected light, of reflected and transmitted energy. Okay. Describes an okay, so we have an don't forget to make your value don't forget to make your 0.1 values 0.0001 in the Cook-Torrance slick algorithm. It prevents pure black, which is what they suggest. Oh, nice. Okay, nice. Thank you. I'll write that in my notes as well. I was gonna I'll write that further down actually. Can I okay, so when you are using the Fresnel, yeah, I feel like I don't know if people have seen some of my videos online on YouTube. I skipped a bunch of this basic stuff, so that's why I'm gonna have to go back over it. Term Fresnel, what is it? Plus Fresnel, it's the schlick function, I guess, for the Cook-Torrance specular BRDF. You'll want to make sure that the values are 0.001 to avoid pure black. Thank you. That's actually really nice. Thank you. E.g. Okay, let's I'm gonna write that in as well. Thank you again, my guy. The help is very much appreciated. So so yeah, DGF. This might be a bit further on. What I'm gonna do is write note in the middle and then have this kind of come up here. So that'd be good. So float 3 spec up. So I'm gonna write that as a vec3 because I'm used to GLSL because which is because I'm a Vulkan guy, I guess. From OpenGL, you know how it goes. Divided by 4.0. Yeah, for example, when you work out the specular components of the BRDF. Okay, so let's keep going. We have times by saturation. Saturates, and then we have, which I assume is a GL. We might have to find the equivalent of that. That might be something else. NV, so that'd be normal and the visible, times by the N.L. I think I've been calling them NOL in this case. It's plus 0.001. Saturate, I think that's a little different in GLS. I could be wrong. I think it's mix. I think it's the same. Oh, okay, so it's clamp. Yeah, I just know that GLSL doesn't have saturate. I didn't realize it was clamp though, which is fine. So we're just going to take that and then clamp that to 0 and 1, it looks like. According to the internet of this random forum. Cool. Okay. There we go. Fantastic. Yeah, I always thank you for that help. That's very much appreciated. No problem. I'll be able to convert it. Thank you, Meta. Sam, how long have you been working on this for? I really want to figure out my career path. All I'm good at is C++. I don't know if I should go into finance or game dev. Well, I can tell you straight up that going into finance will make you rich than going into game dev. They're both quite difficult fields. But if you care about money, and that's a big driving factor, which is fine, by the way. It's not like I'm calling anyone out when they actually care about money. You're going to have a better time in general getting a financial gig versus a game dev gig. Yeah. Game dev is honestly actually underpaid relative to other programming jobs, even not just finance. I think finance is the highest paid. So if you actually do care about money, then I would highly recommend finance over game dev. That being said, a lot of people like me and people in chat who are into game dev, we do it for the love of the game, more than getting paid. So if you have a calling towards it, you've got to understand it's a more of a creative, I guess, field, which means people pay less because it's more people want to be in it. So yeah, that's what I would suggest. Have a think about those two things. How much do you like game dev? How much do you like? Because you can write good high-performance C++ code in either. So they're both very good fields if you care about performance and you want to care about and you care about all this and that. Okay, so yeah, that's what I would say. And yeah, looks like the person in chat also knows his stuff. Yeah, and 100% there. Yeah, no problem. Yeah, I 100% agree with the Meta Hunter there. Is it meta? Oh, whatever. Yeah, so the other person in chat is 100% spot on. Okay, so call me Matt. Will do. Yeah, I 100% agree with Matt there. Yeah, thanks for that. Okay, so reflective trends that we have. What did I say? It is also concerned with the ratio reflects and transmitted energy. Okay, so we describe the inexpensive. Okay, so this. Okay, we have a inexpensive approximation of the Fresnel term. I keep wanting to call it Fresnel for some reason. Read it like an English person, I guess. Okay, so let's write this out. I think, actually, I keep forgetting this website actually has the LaTeX built in, which is nice. It doesn't have everything, but it has most of it. So I can just grab that out. And then I don't have to type it all out myself. Like I was with when I was learning offline ray tracing. Ugh, that went on and on and on. Okay, so we have the normal, which is just 0, and the grazing angle, which is F90. Okay, so let's get rid of these fellas. And this. So we have V, C dot, and then H. Yep. Oh, no, backslash. To the power of 5. Interesting. So the grazing one is just F underscore 90. Oh, there needs to be a backslash again. And there we go. Cool. Yeah. Did I spell it wrong? Okay, so I think we're good. The slick. Okay, so the constant F0 represents the specular reflectance at a normal incidence. Oh, I wrote it lowercase. Okay. Oops. I did. Why did I write that? Let's do a search. Oops. Can't quite see it. Oh, it's just doing every single type. Yep, there it is. Okay. You're right. This should be caps. And this probably caps as well. Yeah, I kind of wrote this real quick, just to get the notes before the chat moved. But yes, I should. It's technically that's how you do it, right? Yeah. Gotta be careful with my. Gotta put the respect on the name. Oh, my bad. I didn't see that. Yeah, I've got dyslexia, so the letters look the same. Yes, I see it. I see it now. Yes. Thank you. I thought it was something else, and I think I've also done it here as well. Yep. Yeah, I don't know what it is about dyslexia. Sometimes you just go blind to stuff like that. You'll be making the same mistake for ages, and then all of a sudden you'll realize. Like I was calling microfacets microfax for about like half an hour, and I realized I've been calling it microfax to really change everything. Yes, thanks for pointing that out. Yeah, it'd be fun to learn microfax about rendering, but I don't know what that would mean. Anyway, the constant F. The weirdest word in the industry, pronounced Fresnel, yeah, but it's written as Fresnel, yeah. The constant F0 represents the specular reflectance at the normal incidence and is achromatic for dielectrics. and chromatic for metal. Okay, so let's write that down. So the F underscore 0 constant represents, oops, constant. My programming was coming through there. Represents the specular reflectance at a normal incidence, which I'm gonna have to define some of these maybe. The normal incidence. So the normal incidence is the which is to do with when you're looking directly down at a surface. Okay, I think that's correct as far as I remember up here. We say that it's how much reflected back. Okay, so that's the grazing angle. So by default, I think. No, I'm gonna say. No, I think that's correct. No, I think it's nothing to do with the angle. I think the angle's to do with the F90. Let me just because I've been so yeah. Okay, so I think I wrote this before I went on the odyssey of trying to get specular working in my engine. You also need to have the instance of reflection material. So in our notes is when you're perpendicular to the surface. Yeah. Okay. So yeah. Okay. So I'm just gonna add that in just for my future self, even though it's a bit wordy. Yeah. Okay. So that's right. And is achromatic dielectrics and chromatic for metals. Nice. Okay, so the actual value depends on the instance of reflection. Okay, so the actual value refers to the IR thingy. Let's bold that guy out. Okay, what else we got? The term in GLSL, this term requires us to use POW as shown in listing 5, which can replace a few multiplications. Okay, so in GLSL we can use POW, which removes a few multiplications. Yeah, because we haven't multiplications. Oh my goodness. All right, cool. Let's write that out, and then we can at least throw this version in. So, yeah, I really don't think we have this, do we? No. That's why I'm going with C. I just in case an update came. So the Fresnelli Schlick. Alright, so let's write this out. Messing about there. Float U, which I don't like, so I'm going to rename F of 0, which I do like. I don't mind that. Float 9 F of 0. f of 90. But we need to figure out what this u is. Oh, it's v. It's the viewing angle, right? Why is it u? VH, which is the half angle. Right, I'm going to name this as V. I don't actually know when it comes to this code. What is it referring to? Anyway, f of 0 plus vec3. Make this an f90, I guess. Minus f0. The thing I don't quite understand about how to calculate this is when I get this out of the model, it's a floating value, right? It's a floating point value. But when I'm looking at this code, it expects the I see. Okay, so no, sorry, I got confused. I say we get the instance of reflection out, which is a floating point value. So that means with Fennel we need to make that. How do we get a vector out of this? That's the thing I don't understand. Obviously you could just make a vector out of that value for every single point. But I'm not entirely sure. So that's just the power. Yep, we can just do pow. Okay, so yeah, it's. I think this is like the more valid one down here. So I'm not going to use this one because the less arguments the better. So I'm just going to kind of leave that one there and just be like, okay, this is kind of useful to know. Yeah, I feel like your note needs to be pushed down. I'm going to keep pushing this down until we get to combining all three together, which I think is coming up. Oh, no, it is. It's coming up. Okay, we'll put it at the end of this. I just got to make sure my notes are ordered so I can read them in logical order from top to bottom. Okay, so let's write this right. Okay, let's. The Fennel function can be seen as an interpolation between the instance reflection, the instance specular reflection, and the. It's at the grazing angle, represented by F90, which I assume that's what it means. The observation of real-world materials show that both dielectrics and conductors exhibit achromatic specular reflectance at grazing angles. Okay, and the Fennel reflectance is 1 at 90 degrees. A more correct F grazing is in section 5.6.2 using f of 90 set to 1. The Schlick approximation for the Fennel term can be optimized for scalar operations by reflectance. By refactoring the code slightly, you get this result. Okay, so if we just set the f of 90. Okay, so we have f of 90 to 1. We can make this we can interpolate we can optimize this optimize, I guess, simplify, I don't know, the equation to operate on scalar operations by refactoring things little. This is due to the fact that reflectance of grazing angles represented here by observed in real world materials, both dielectrics and conductors exhibit achromatic for real world dielectrics and conductors exhibit oops, that's not how you spell anything. Exhibit achromatic specular reflectance. Right. Yes. Right. Okay. So. No, I think this is separate. This is separate. Yeah. Okay. Right. Let me. It was this way around for a reason. This is a comment on the one above. Okay, so meaning that this is slightly incorrect. Right. Okay. So that's what I think it's telling us. If we do that, then we interpolate between the two values, then we get this value. Okay. And so let's go with C. Vec 3. Slick. I'm slick with this one. Okay. Then we do float. Oops, come on. U. V again. I think it's the viewing angle, honestly. Vec 3. So then we got our lovely message from Matt earlier, which we can add on the end. Which what I'm gonna do after this, guys, is I'm gonna write this function, and then I'm gonna write. Okay. Then I'm gonna at least get the specular part of the BRDF. I think we're gonna use Lambert specular for diffuse for now. Although I'm gonna do it slightly incorrect until we actually hit that point, so we can actually see what am I doing? I was running it like minus F. Okay, so I'm going to take that out and go into our shaders. And that's our third function that we've written. And right, so and the other thing we need to consider is make sure this is never so it looks like divided by, so this is our specular. Okay, so I'm going to use I hope you don't mind there, Matt. I'm going to use your one. So I'm going to throw that in there. I'm just going to rearrange this a little bit. Okay, so specular. So this is what I started with. Let's build these up a bit more. Right. And we're going to take DGF. I'm going to separate these out. Yes, 100%. Thank you for the clarification, but yeah, that's what we're going to build up. So we have float D. For that, we have float G. This is the benefit of doing the studying. I understood exactly what you were doing. And Vec 3F for Fennell's. What did I call it? So we need, I believe, as far as I can tell, I swear we just need the V vector, right? I'm going to look ahead of the book just because I don't know what vector we're using here when it comes to this particular thing. So no, he uses L.H. So it's the half vector and the light vector. Interesting. Oh, is that because, yeah, okay. I think that's the grazing angle, right? It's the camera minus, okay, thank you. So I'm going to write a note here. So camera position minus world is the U. That's even better than what's happened here. So the camera, we have a terrible, please excuse this horrendous use of the lighting direction. So we have, that would be the lighting direction. So what is our camera in this case then? Do we have our camera in here? We should, because we did this earlier on. Let me look at my older shader. Just because we're rewriting this guy. Where's our lighting? Yes, yeah, so we have the scene. There's our world position. Where's our can we get our camera out of this? Scene data. Give me a minute. So we have camera position. We have the view projection matrix. But I don't think we have the camera position. Maybe. Lol. Let me help as well. The V is yes. Please excuse the horrendous. I threw it in there just to actually test things out. Okay. Okay. Let me help. V is a normalized vector difference between the world position. And the camera's position. Thank you. I didn't quite understand. Of course, that's the viewing angle. Of course. Okay, that makes a lot of sense. All right, it's just clicked. Why? Okay. Okay. Right. Okay, let's make this better then. Let's yeah. Okay, so that would be if I'm in my old shader. Okay, so yeah, how would you else get the viewing projection? So in my, yeah, thanks for that, Matt. Of course, that's the distance though. We know the viewing angle. Yeah, we literally don't have the camera position apart from getting a vector. I can reconstruct it, I think, with the view projection matrix, but so, okay, so you've said L is negated plus normalized direction plus light. L is clamped plus normalized dot product of H and L. Fantastic. Okay, so as far as I can tell, we don't actually have a correct V value. So our current V value is, let's just see where that comes from. So this is, let's go back to our new shader. Because we're in the, yeah, excuse the scruffiness in this. As people used to say, that all the tools are on the garage floor right now. So where is the V vector come from? Let's call this like a view vector or something. Easier to find. Is the TBN? Oh, here it is. Okay. That's correct. Okay, so it is the and you said, okay, so we got the V vector. Thank you. Okay, so it's all just, yeah, brain fart. It's all coming together now. It's okay, so now we need to do V is the normalized vector. Yep, difference. L is negated plus normal light direction. L is negated plus normal light direction. Yeah. So then H is clamped. So yeah, H is clamped. So I have, let me change the music as well. I feel like we're on Mega Drive Central right now. Just real quick. Yes. I mean, I don't mind the Mega Drive music, but yeah, well, let's play out, and then I'll just randomly pick something else, hopefully. So the finale clamp. Oh, thank you. This is so useful. I got you. So fantastic. Okay, so we just don't want to use raw.l.h because that stops us getting the value that we need from being 0. So then we do dot. Yep. And then we got h. Do we have a capital H as well? Why is there a 2? Where's this come from? I think that's completely wrong. Give me a second. I just noticed something. I think it's supposed to be L. Oh, N. Right. N.H, literally. So a H, we are doing H. B. And then just want to clamp this to 0.001 and 1.0. And then F0, which is... Oh, hang on, I did that wrong, I think. No, F0. Okay, so this is the confusing part for me personally. Is the F0... What should the F0 be? I've never quite understood this. So I've got the instance of reflection out of the shader, out of the material. So here's that, which I assumed was... So I don't... when it comes to the... Because it needs to be a vector, right? I thought it was this, but I don't think that's the case. Oh, is it? Is that lit? Oh, okay. Thank you for explaining so much, honestly, Matt. Because I've tried multiple times to figure this out. You can use... Thank you. Let's, we have lerp, right? That's a thing. In GLSL. Ah, right. That, yeah, because that's the most common, isn't it? 0.04. F0. Thank you. Flip it back. Thank you for this. So my albedo is base color, and I think it's RGB, and metallic is... So where do we get the metallic from? We got that from a texture. And there's the metallicness. So this the blue channel contains the metalness. Okay. Oh, what am I doing? Can you do that? Like lerp between a vector. I guess we'll find out. So then F0 goes in here. Now let's just make sure I've got the syntax. I think I got the syntax wrong or something. Let's just build and see what happens. The 200 and... So we don't have a metalness vector really, we only have a metalness factor. Yeah, no problem. I guess GLSL's a bit naff compared to it might be lerp 3. Let me let me look up the GLSL lerps. There's mix. Yeah, okay, so I think we want mix. Yep. Okay, so we get past that then? No. Dang. So it needs to be float. So I think this needs to be this way around, right? By the looks of things. 0.04. Nope. And this returns a gen type, gen type, gen type. I want to be able to lerp between, mix between. Specifies the start of the range. Specifies the end of the range. Specifies. Okay, so the start and the end. This is. Hang on. So I assume we're lerping like this. I think that's it. This is the start, this is the end of the interpolation. Specify the value to use between. Sorry, I'm getting a bit mixed up, I think. Okay, mix performs a linear interpolation between x and y. Okay. Got you. Thank you for thank you bearing with me, by the way, Matt. It's very much appreciated. You're becoming like the MVP of the stream. Yes, okay, so we got that far. Thank you. So we got to, which makes sense because I haven't actually finished this yet. Redefinition of specular. Let's get rid of this. And what else are you moaning about? Okay, that was it. Then we have this terrible way of working with direction. So, and then we go from high dynamic range to low dynamic range right at the end. That's what that is. Okay, will do. Yep. Ooh, interesting. Let's have a look. We are certainly wow, this is a cool effect. Alright, so let's change all my values at least. Oh, my bad. I literally just have specular. We don't have diffuse because we haven't done that yet. So Lambert, let's just do a very dirty. Yeah, don't worry. That wasn't you, by the way, Matt. That was me just forgetting to do this. Okay, so whoa. Are we doing diffuse twice? Hang on. Let's actually get the diffuse in here with the actual value. So this is actually a really simple 1 over pi. If I just... yeah, it's just 1 over pi, which we do have already. So I'm just going to throw this in and kind of like try and get this correct. And then we'll correct all the values. So now we have diffuse. Lambert diffuses. Get base color FD. And now we're gonna, instead of just doing base color, we're gonna do this. And to do our lighting. So we need to do any zero, so including, I assume this as well. Needs to be like that, maybe. Okay. Let's turn this off. So I think let's turn our intensity down, maybe. So there's light intensity of 4. I haven't actually gone into the details of this yet, but let's it could be that. So maybe it's too intense for what we're trying to do. Okay. Okay. Looks good. Okay. So let's look at things. This is a... Huh. Don't quite understand why that's happening. Okay, so let's continue on what we were doing. So we got the... So I'm going to get rid of the finale thing for a minute and just check individual parts. That makes sense. Let's kind of see, like, if I remove bits. Oh yeah, this needs to be a. So we're going to make this just 111, I think. You forgot a... Oh, did I forget something? You spotted. You should also fix your clamps. Is way too black. Yeah, no problem. You also forgot a floating... Oh. At line 270, what do you see? Oh, yeah. You're right. I didn't see that. Thank you. I see. Yes, we got that done. Let's just see how that affected things. Oh, we have an undeclared variable. Okay, so that... okay, so I think we're getting there. So if we go to this rock... and yes, I think you're right. My values are way too dark. So let's increase the lightness. Okay, so so if I take this. I'm kind of curious. Let me... I know you didn't say to do this, but I'm kind of curious. Like, what does a looser clamp look like? I'm kind of curious. Oh, okay. No. No. That's not good. That was even worse. And this needs to be another 0. 2 zeros even. Okay. You don't have ambient strength in your system. That's why it's rendering the black and white 2 clamped. Ambient strength. Let me look at that. Ambient strength. When it comes to graphics. Is there a... Oh, okay. Let's put safe search on. I got a bit nervous then. Okay. Is this ambient occlusion? Is that what you mean with ambient strength? Sorry to ask you questions, Matt. By the way, Matt, you don't have to help at all, by the way. I just very much appreciate your help, by the way. It's very much appreciated. You know, everyone's job in the stream is just to chill in any way that have fun in any way they want, assuming they follow the rules. So yeah, don't feel like people who are other people who are watching, like because they're not participating doesn't mean that they're invalid. You know, it's completely valid to just chill. So if I raise the base colors, no, what is it? The base factor. Where's that come from? Where's that gone? Hang on, I think I've lost something in my shader. So there it is. Where's that gone? Yeah, because I want to get rid of the blacks. That would be really good. It's too dark in this scene. Also, you don't have ambient strength in your system. That's why rendering black on white's too clamped. Okay, so we'll just go through more of the book, perhaps, and instead, no worries at all. Appreciate that. So instead of sending code, I will explain ambient, then just watch. Yes, please. Yeah, everyone's job in this stream is just to have a good time, no matter what that be. If I ask you a question and you don't want to answer, that's also chill as anything. I thought I removed the Final Fantasy VII music. Hopefully that doesn't get copyright strikes. Oh well, it's too late now. So anyway, let's keep going. Let's yeah, I think I'm gonna have to eat at some point, which is also fine. So we've made a load of progress. Like it's actually kind of shocking, like how much progress we've made. Let's run this again. Okay, interesting. What have I done? I feel like I've... Jeez, I have messed up something there. Let me go back. Oh, that's what I did. I deleted 0. So the intensity is mega high. Yeah, okay, so... Still though, we got like weird artifacting. Like this. Which is kind of cool, but kind of looks weird. I'm going to turn... If I turn off the light, I'm just going to turn this off for a minute. Let's just see... With no lighting at all, what is it? Is it just going to be black? Okay, so it's just going to be bright white. Okay. Hi, Frosty. Good to see you again. I want to set up a... I just want to set up a small application dev track. And it tracks exactly how much work is being done. Sure. If the window is active at the moment, it tracks. It does not turn off. And put logs in a small SQL application. It's an interesting project. Yeah. Put small logs in SQL application. I will write it in CPP or Python. First, I will set up a terminal. Okay. In my opinion, if I don't, that sounds like a big undertaking, by the way. So what I would do with that is, it sounds great for a first project for the summer. Yeah, just I will set it up, send you an execute, then I'll send. Yeah, sounds good. With SQL, right? it's often easier to handle things in Python. So that is something that I would consider. C++ is you're gonna have to use like a library. There is what I would recommend if you want to do that in C++. If you don't mind me explaining this, what I would do, if it's not going to be super straightforward, but I think if you want an application, you can use something called Qt, and this has you're learning. If you do this, is a massive heavyweight library. It's a UI library, and it requires a bit of knowledge on how to set this up with CMake and stuff. But if you want an application that you can click on, that's and you want to use what is it called? Like getting a like this will set up like the supporting libraries around C++. So yeah, I would if you really want to make an SDL application, this is personally how I would do it. SDL, SQL, sorry, SDL. But it's like you'll be learning Qt and C++, if that makes sense. It's more than just make an application. I've used this as a professional. So but like I said, it's big. It's a big thing. It's not like a small IM GUI type thing. Okay, so there you go. Okay, so ambient. Okay, let's read this. This is important. I'm gonna write some notes there. Matt, hopefully you don't mind. Ambient. Yeah, because a lot of my knowledge of graphics is purely. It's very weak in comparison to other things. Now, please don't argue in chat about anything. I don't want that type of thing in the chat. Yeah, don't call each other names. If that's what's happened. Ambient is defined. Yeah, and also keep it in English, so I can't read any other language, and that's just to help with moderation. Or use the auto translate thing. I think Google is also translating things. So the okay, let's get back to this. Ambient is the definition of the environment of its if the environment is pure lightness. I see. Lightless, or have some basic light that feeds the environment. Sure. Since you're not doing ray traced light, I highly let's see. It's a very good idea to suggest to boot. Okay, so if I do this, I think what ends up happening is we get like pure albedo, nothing. So that's like pure light, pure color, right? Oh, I need to put the intensity back. And I think that would be the opposite. So let's put the intensity back. I think there was a misunderstanding there if he didn't call you a fascist. Don't worry about it. Let's just move on from that, Frosty. I want to post it on GitHub after I'm done for people since I'm a procrastinator. I know it will fix my problems. I know. Yeah, go for it, dude. I really appreciate it. Yeah, post it on GitHub. Yeah, go for it. Yeah. How do you know? Or is it the other way around? Let me think about this. Is it the other way around? Oh, I'm messing around with the wrong thing here. So what I'm going to do is take the color factor and multiply by, instead of that, let's just do 1, right? Let's do the opposite. Let's do 0 as well, just to keep working this out. Right. 0, let's do 0. So if we multiply this by 0, we should get blackness completely. Right? Yeah, okay, so that makes sense, right? This is, we got like a vector, we've multiplied by 0. 1. Okay, so this is going to make things darker. We need to make things lighter, actually. I've been hanging out here for a week now. Yep, and I used the automatic translator. Did Mr. Streamer knock it out? No, you can use the automatic translator as long as it comes through as English. That's fine. Also, if I want to use ambient, you need to add outgoing reflectance. Which is called LO. I see. Yes. Okay. So I've seen that in the rendering equation. Right. I am familiar with what I was talking about. I just haven't implemented yet. Yeah. Thank you for the help there, Matt. Yes, everyone's allowed to use as long as I can read it and I can understand what you guys are saying in English, then I don't mind how it comes through, as long as it's just to help with moderation. You know, because there are some people online that would, you know, say slurs in a different language just for no reason. And yeah, that's the reason that we that's the reason it's a rule. Yeah, don't worry, guys. Just move on from this. Yeah, I don't want arguments in the chat, please. It is what it is. We'll just say that. It is what it is. We get back to chilling. So color factor, right? So, yeah, I'll keep getting right. So what I'm going to do, guys, is I'm going to pick a video and just eat some lunch, which is going to take me like 15 minutes. I'm going to stick that on. How's that sound, right? If you guys have a video that you want me to watch, feel free to suggest it. So it takes me about 15 minutes. I've timed myself now. But yeah, because I've been streaming for X amount of hours, I don't know. I'll need to be able to. Oh, I didn't time any of that. Let's add that in. So I think I paused for a reason, so I'm going to say 42. Whoops. That was my Windows noise. Watch any of the Oscar Scrims videos. One of my senior graphics friends who works at... Yeah, we're going to watch that then. Thank you for the suggestion. Yeah, I can tell you're pretty cracked when it comes to graphics programming, Matt. You know a lot of stuff. Let's have a look. I see. Yeah, let's give this guy a watch. Give him a subscribe as well. No, why not? Seriously, please watch this before upgrading to Direct 12. What have we got? Let's see. How to simply... I learned 8 games in 800 days. Let's see what we can do. Shader tips. What have we got here? Let's see something interesting. Genius graphics optimizations you need to know. Right, how about that, guys? That's going to take me that's going to take me my whole eating time. That sounds good. All right. So I know some loads of languages. Yeah. I think the translation broke briefly, but I don't think anyone should worry about it. Let's just chill and get some music. What I'm going to do is turn off the music for a minute and try to organize my OBS so it's about as loud as me. Typically, we want about 70. So I'm just going to be right back, get some food out the fridge, and then go to push to talk because you don't probably want to hear me chew. So I'm just going to do this real quick, and clattering of cutlery. It's not exactly the most interesting thing to listen to. So yeah, I will go and be right back, guys. Thank you for bearing with me. Ugh. Yeah, I make a pack lunch so I can stream longer. Gotta do it to get better, you know. Right, okay, so let's get this video up. We'll see what see what the audio sounds like for you guys. So I'm just gonna play it a little bit, check the audio, okay, and then make sure that you guys can hear it and are not getting your ears blasted out, you know.
Ever played a game with the crazy amount of details yet running butter smooth? Most people will probably.
Okay, I think that's a bit quiet, so let's turn him up a bit, and then.
But that would be a disservice for all the people that have implemented awesome techniques that will.
Okay, that'll do, and I'll restart the video. And yeah, I'll go and push the talk briefly. And yeah, let's enjoy this vid by Oscar. Looks like. Hopefully, I'm saying that right. Right, and like I said, I'll go and push the talk, but I'll be done pretty quick. Doesn't take me long.
Ever played a game with the crazy amount of details yet running butter smooth? Most people will probably attribute this to hardware, but that would be a disservice for all the people that have implemented awesome techniques that will stand the test of time. So here are genius graphics optimizations you need to know. Be sure to stay until the last point, because I've gone through more than 20 frame analysis of well-known games, and all of them has implemented this well-known technique. But let's first start at the top with frostum culling, one of the simplest, but might as well be one of the best optimizations out there. Our view as a camera is a pyramid with its top chopped off. This is called a frostum. Inside this frostum, we check against the bounding boxes of each object, and if it's not inside and it doesn't intersect, we don't have to render the object at all. Occlusion culling works by determining if something is occluded by another object, if a camera can see an object or not, by it being blocked by another geometry. This can be done on both GPU and CPU, but most simply, it's by having a low poly version of your model and doing ray versus triangle on the CPU. Front to back and biggest bounding box rendering. Another simple trick we can do is render things front to back to minimize overdraw. Overdraw is the issue where we render the same pixel multiple times, but it's going to be discarded because it's occluded, so it's wasted memory. One thing that people don't think about that much when having distance-based fog is that you can do a lot of tricks with it. One of these is just to bring the far plane closer to you and try to align it with the 100% density of the fog. Instancing is the act of trying to group together multiple things into one draw call. We do this by sending up the model to the graphics card once, then we call draw instance with how many instances we have, and we also have per instance data, which is transformation for each of the instance, and then by the graphics API already implementing this, we get instancing. A non-built-in version of this is batching. Instead of relying on hardware, we take all of our model's data and put it together into one big model. Then we just render this one big model just like per usual. Dynamic terrain tessellation. If you want to have a smooth terrain, you need it to have a lot of vertices. But this is not scalable if you have a huge terrain. This is why we can dynamically do level of details around the player. The closest section to the camera has the most amount of vertices, and the ones further out have lower. Having realistic lighting and material interaction isn't really an optimization, but how we do PBR definitely is. Because of how many tricks we use, it should really be called approximated based rendering. Things like microfacets simulating bumps on the surface, Schlick's Fresnel approximation, the ambient light just being a coefficient, and not having 100% energy conservation. Image-based lighting, one of the simplest way to simulate global illumination, GI. Take a screenshot in the world in a cube-like pattern, we call this a cube map, then have it have a position in the world, we call this a probe. Blur the cube map, it's not really how we do it, but it's just a simpler way to do it, and then we apply it when we do rendering. Spherical harmonics or light probes. Having multiple light probes and storing them inside spherical harmonics. Just like the previous point, we want global illumination, but now we want it locally. So let's say we have green grass, we want the wall next to the grass to be green. Therefore, we place more than one probe in the scene, but this is very inefficient because of the cube maps we will store everywhere, it's just so many textures. And that's where spherical harmonics take place. It's just a way to store the cube map information in a way more efficient way. Just like GI we store probes, but they are blurred, we can also store them unblurred, and we can use this.
Dimitri, don't worry too much. I'm not kicking you out. I'm not excluding you, that's all. The only reason that I need it to be in English is just so I can moderate the chat, that's all. You can use the translation feature that you've been using. Yeah, everything you've been doing up until now has been absolutely fine, so don't worry. There's nothing wrong. As long as I can understand what you've said, regardless of how that comes about, whether that's through a translation tool or not, that's fine, okay? Yeah, so you got nothing to worry about. Sounds good. All right, let's get back into it, and I will avoid the chewing. Yeah, so don't whatever you need to. Yeah, don't need to worry, Dimitri. You're doing fine. As long as no one argues, that's all. It's not a translation. It's not a translation. It says it's not. It's not a translation. Say it's not translated. That means my message won't get through, and I need to redo it. I see. Okay. There's nothing. Yes. In that case, that's right. See, in that sense, I don't mean for you to see Russian. Yes. Yeah. As long as you're trying your best and everything that you're doing is fine, Dimitri, then if I see Russian every now and again, I'm not gonna get really angry or anything like that. You're doing your best, and if the technology breaks and something happens, don't worry about it. Yes, so you don't worry. Also, this video is so good. I want to implement all these features. It's a great recommendation by Matt. All right, to avoid chewing on the video, I will let the video play while I chew and eat.
For reflection, and that's called reflection probes. Planar reflections is also a great way we can do reflections on flat surfaces like mirrors and on water. You essentially render the whole scene from the plane's point of view, but you can run very simple shaders and low res. Light mapping, a very fast way to do static global illumination because we pre-compute the lighting and store it in a texture, also known as baking. Each object gets an index or a UV that corresponds to the slot in the texture when applied in shading. Photon mapping simulates GI in scenes by saving light hits, photons, on the surfaces, and then using them to approximate the light calculations later. It's a great optimization because it simulates how light would interact in the scene and how caustics would bounce in the scene without ray tracing. Voxel-based global illumination approximates GI by dividing the scene into 3D cubes, voxels, and storing light data inside of them. This method is faster than normal ray tracing because instead of doing it per pixel, we can do it per voxel. Screen space ambient occlusion, or SSAO, is a great way to fake shadows in places where light would never hit. It simply checks how much the pixel is surrounded by other geometry and take the estimate of that. Deferred shading is a great way to optimize light calculations. Instead of doing normal light calculations, we render the geometry to specific render targets like albedo, normal, roughness, metalness, etc. We then use the render targets, also known as the G-buffer, together with the light data and do them all together in one place. Light prepass. Traditional deferred rendering, just like I said, separates the rendering into two different components, the G-buffer and the lighting calculations. In contrast, light prepass instead just calculates the light directly, and then we just have that texture, so we get away with some data that we don't need in the G-buffer. This means that the G-buffer becomes smaller. Acceleration structures or data hierarchies. Acceleration structures is just a fancy word for a data structure where we can look up things fast. There's no way I could fit them all in this video, but I'll just mention some of them fast. Bounding volume hierarchies, KD trees, OC trees, BSP trees, and grids. Tiled rendering. If grids are cubes in 3D, tiles are the same but in 2D. We split the view into tiles, and then we have the lights intersect with the tiles, and if it intersects, we just put it in that tile. This is really fast because we isolate the lights into different regions of the screen. Clusters, also known as forward plus. Clusters is the big brother of tiled. Tiled is in 2D, covering the entire screen, while clustered is in 3D, covering the entire frustum. The exact same technique is used here, but now instead we can use the light's actual world position and position them in a cluster. Another fast way to get away with not doing ray tracing is screen space reflections. It's almost the same, but it works on screen space and uses the G-buffer when doing path tracing. Pre-computed radiance transfer. Commonly used in subsurface scattering, pre-calculates how lights interact with different material properties using things like we said before, spherical harmonics. By pre-computing this data, we don't have to do it in runtime and we can just sample from a texture when doing the shading instead. Stencil shadow volumes. Project silhouette of an object onto the stencil buffer. It worked quite well for hard shadows, but it cannot do soft shadows. Popularized in ID Tech with Doom 3. Shadow Atlas. This is a must if you want to have per light shadow casting. Shadow atlases are usually constructed in a way that the lights that's closest to the camera have the highest resolution in the shadow atlas. And the further away they are, the lower resolution they get. Cascaded shadow maps. This is having multiple shadow maps with a varying amount of size. We have the highest resolution of the shadow maps closer to the camera and the lower resolution going further away. This really makes a difference when we have large viewing distance and can see shadows far away. Variance shadow mapping. Store two depth values for each pixel. The mean depth, which is the average depth from the view, and the variance, which is the spread of these averages. This allows you to filter shadows using hardware techniques like mip mapping and anti-aliasing, reducing the need to do depth comparison and filtering like PCF. Resources. Mip mapping, a very essential technique used everywhere in the pipeline. Essentially just storing lower resolution versions of the same image. Texture channel packing. A way to think of a texture is not an image, but more of a data structure where you can store whatever you want inside. An example of texture packing is just storing the X and Y component of the normal and then computing the Z component using the cross product. If we also have things that are either on or off, we just need one byte, so like metal, and therefore we can pack these together into one channel and then we can bit shift wherever we want into the texture. Bindless resources. We want to send as little data as possible to the GPU. So what is not a better way than to just send it up once and leave it there? This is exactly what bindless resources does. We instead have an index we send up and say where in this resource we want to sample from. This can be used on textures, models, and other resources. Mega textures. Mega textures are kind of what they sound like. It's an insanely large atlas. This can example be all the albedos in the scene, or all the metalness, or all the normal maps. This helps a lot with performance, because just like with bindless resources, we don't have to bind this all the time. Resource streaming. Another way to not send things to the GPU unnecessarily is just sending things that are visible for us. So when moving about in the scene, resources will be swapped in and out depending on what you see in the scene. Sparse virtual textures. An extension of the two previous points is sparse virtual textures. This is where we can have a large atlas, like a mega texture, and just load in parts of it depending on where we are in the scene. Optimizing models. A simple way to optimizing that is often forgotten because of new tech is just simply to optimize your models. Having less triangles is always better, and having your own format, like a binary format, is just way better in all different ways. Level of detail, or LOD. Level of detail, also known as LOD, is a way we can have different detail level of, example, a mesh, change out in runtime depending on, for example, view distance. Usually we have different models we can choose from, with varying amount of vertices, with the last one just being a plane. And this always points towards the camera, and it's a billboard, also known as an imposter. Dynamic LODs, also known as virtual geometry, and by Unreal standard known as nanite, is also a way we can do LOD, but dynamically. But it has its drawback as well. Code and shader optimization. Caching. One way we can really help out the GPU is just by not using it. Caching is the act of saving things and reusing them instead of recalculating them when we don't need it. For example, this can be UI. Minimize state changes. Much like using bindless resources, minimizing state changes is a great way to optimize. If we group together things that has the same stage, we only need to change state per group instead of per object. Branchless shaders. By doing less if statements, you not only reduce compile times, but also reduce branching in your shader. Branching is when we can't deduce the output to one thing, but it's either or. This is bad because it reduces parallel efficiency. And since pixel or fragment shaders run on per fragment basis, it's a lot of branches. Ray marching, or even ray tracing, can be really expensive against complex geometry. So how can we solve this? This is what sign distance fill is for. We just simplify the shapes. Compute shaders. GPUs are parallel processing machines and are really efficient with it. So some things are really good to send up to the GPU to calculate. But there's one issue with this. Threads really don't have a good way to talk with each other. So for this reason, there are a lot of things that we cannot do on the GPU. But particles are often an exception to this, because they usually don't have to communicate with each other. Asynchronous compute. We can take advantage of the fact that low-level graphics APIs enables us to asynchronously queue different things like render, copy, and compute. This enables us, for example, to render the scene as per usual on the render queue, but also copy resources from the resource queue, like streaming in textures, but also doing compute things, so calculating particles and physics on the compute queue. So everything is very asynchronous. Temporal reprojection. Temporal reprojection is a technique that uses information from the previous frame to improve something in this frame. Often used in anti-aliasing with things like temporal anti-aliasing, TAA. But it's also used to stabilize the images and optimize things that would otherwise take a lot of computation. And when mentioning anti-aliasing, we cannot skip over FXAA. Although maybe not the most elegant solution, it's very fast and it does its job. It smooths jagged edges by analyzing the contrast between neighboring pixels. Hierarchical Z-buffer, or High-Z. Used as an optimization for a lot of different techniques, like screen space reflection and ray tracing. You essentially create a MIP chain of the depth with varying resolution. Depth peeling. Almost like High-Z, but instead of storing different resolution of the depth, you store different depth slices just like a 3D texture. Bitwise transparency and alpha stripping. A fast way to calculate transparency is not doing it at all. Transparency means full opaque or full clear, and translucency is where some color goes through. We can discard clear pixels, like in foliage, with using alpha stripping, which just removes the pixels in a checkerboard pattern-like way. This is really useful for distant objects, and it can also be smoothed out with post-processing. Logarithmic and reverse depth. Both logarithmic and reverse depth take advantage of the fact that floating point precision is higher towards 0. This helps a lot with z-fighting, but it also gives us a more accurate depth buffer, which results in us having better culling and less overdraw. And the most well-used graphics optimization that everyone uses is depth prepass. This technique involves rendering the whole scene, but only with the depth, minimizing and almost eliminating any overdraw. Because we render the whole scene, it's not always an optimization, but in cases like AAA games, where each pixel does a lot of job, it can be highly effective. Even though hardware plays a big role in optimization, without techniques like these, we would be nowhere. These genius graphics optimizations are just a handful, and there's so much more. And
Dimitri, I can answer that if you want. We'll finish this video.
Each time you delve deep into a new topic, you will find endless of them. But the best way to understand what and how graphics optimization works is by understanding the graphics pipeline. That's why I recommend watching this next video that covers just that in depth.
So, meshlets, which I'll demonstrate with changing. Just give me a minute. I will change something in my shaders. So I'm just going to remove some of this stuff. And let's move my. This is going to take a second to compile, but I need to. If I'm going to change something in my shaders, yeah, just bear with me for a moment, and you'll be able to see it. Basically, I'm going to show you what a meshlet is and what they're used for. It's been a while since I've used my other engine, so bear with me. I just want to turn on the debug view, so find debug. That's what I'm looking for. Nope, that was my Windows noise, not you. Let's see. Where did I put this? Yeah, I'm going to open up my project and see what we end up doing. But yes, Matt is 100% right here. So let's get to my shaders. Okay, let's just run and see what we're up to. I might already have the debug deactivated. I hope. Yes, there are a group of triangle of vertices that get grouped into a mini. It's a meshlet because it's a small. Oh, okay, cool. So this is my older engine that we're trying to match with skill. Effectively, I'm trying to catch up with the knowledge I should have known when I tried to do this. So Dimitri, if you look at this screen for a minute, these patches are meshlets. These are groups of vertices that are triangle based or whatever. And I've colored them in depending on the meshlet. And this allows us to do a lot of different things. This allows us to do culling individual meshlets. And so instead of culling individual, like a whole model. So this is a big model, right? This is like big. There's nothing in here that we can really cull immediately because we'd be culling the whole thing because this is one big model. But with our culling, we can actually, if I bring this back, one moment. So I kind of snuck this all over here. So if I turn off if I freeze the camera and I spin around, you'll see that lots of stuff has been deleted. This is what we're doing in real time. We're actually culling meshlets against the camera. So if I turn it back on, this is what it allows you to do. So, ta-da! It's back again, right? And if I, again, freeze the camera and then turn around, you should see that everything's been deleted over here as well. The reason the floor hasn't been deleted is because it's literally just a triangle. It's 2 triangles. But this is what meshlet optimizations allowed you to do. You can actually delete parts of meshes. Now, there is extra complexities when it comes to this. You have to worry about when you're animating the meshlet to move. Like animation changes the actual group, the group of vertices. So yeah, it's this is what meshlets are, and this is what I spent a year doing. Yeah, thanks, Matt. Like this. I'm also doing meshlet culling, mesh culling in the vertex shader, but like this, when you're doing a vertex shader, you're drawing them triangle by triangle. Yep. When you do meshlets, yes, you're grouping them together. That's exactly right. Yeah. So Matt's 100% on it there. That explains a bit more what's going on. But that's what increases. I didn't think it actually does increase parallelism. So yeah, I'm in this weird situation. So you may be wondering, like, why does this guy know about meshlets? Why has he implemented this thing? And he doesn't know anything about lighting. That's what I'm trying to catch myself up on. I've like spent a whole year. I spent a whole year basically doing meshlets. Well, 9 months. And mesh shading. Because I thought, oh, this is just a simple thing to do, I guess, because I didn't know any better at the time. And now I'm like way behind when it comes to like general graphics programming that like all graphics programmers know that exist out there. Because I was like doing this instead of like learning how basic lighting works and cluster culling and I did do this is all ran through the G buffer as well, so I do have a G buffer. And I do a pre-depth pass, which is what we just learned about in that video. So there's a bunch of like stuff that I can do, but there's a bunch of stuff I can't do at the same time. So I'm like I'm really imbalanced with my skills, I think. So yeah, there you go. I hopefully explained meshlets, and with Matt there, you now know that. Why I'm saying this, Dimitri, is be careful with learning. Learning meshlets if you don't know basic stuff, because I've made that mistake. Got it. It's like a vector, but it can be rendered by a range. It's like we basically have we just group triangles together. So what we do is offline. Well, you can do this in different ways. The way I do it, I use something called the Mesh Optimizer library, which, oh my goodness, a bit rusty on this one. And the Mesh Optimizer library allows us to group triangles together in a way that builds up meshlets, and then we send up meshlets to the task shader, which does culling. Yeah, so C++, way more. And then we send these up to different shaders which do 2 different things. The task shader typically is going to remove meshes, and then the mesh shader is going to meshlets. Is going to remove meshlets. Sorry, for occlusions. It's going to do all the stuff if you want to use it. But yeah. It's not like it's not like we have to use buffers that pass things from shader to shader. If you're using this allows you to do like more GPU driven rendering. But the downside is that not all GPUs support this. Older GPUs don't anyway. It's the oldest GPU that I know of in the NVIDIA range that supports this is the 1650 GTX series that came with meshlet support but not ray tracing support. So basically, if you have a ray tracing based GPU, you pretty much guaranteed to have. I don't know about AMD. You're pretty much guaranteed to have meshlet support for mesh shading. Yeah. So that's what we end up doing. But yes, so more C++ way of explaining it. Standard vector, standard array for each array is being processed. Yes, that's a really good way of putting it. Yes, so we have a standard set of, I have 64 vertices in each meshlet, and because it's a triangle mesh, yeah, we are sending up, these get processed individually, and they get handled individually in a task and mesh shaders. But again, before I did this, I should have learned a bunch of other stuff. I mean, there's no real order to like learning graphics, but after the problem is when I got this far with this engine, is the reason I made another one, is it got too complicated too quickly, and I didn't really need meshlets. What this broke for me is I didn't know how to handle skinning when it comes to animation. So when you deform this model based on animation, for example, let's say this curtain moves, like let's say it's like wind happening on this curtain or some physics or something, like these vertices are going to move relative to the camera. So if I do a freeze the camera again and I cut this thing in half, now all this gets deleted, but let's just pretend for a moment that while my camera's here, the gaps in this come over where I can see, and it kind of, you get holes in the model at the edges, sometimes like in the middle if the animation's pretty big, but it really tripped me up, this. That's a really rough topic. I didn't even test with meshlets. Are you saying that it is impossible to render an interval like 1, 2, and 3? Interval. Yeah. I just I'm not sure what that means. Interval. Do you mean like an interval as in the meshlets themselves? But anyway, that's me. That's why. Like, this engine is very tied to a particular book called Mastering Graphics Programming with Vulkan as well. So I kind of got stuck implementing a lot of things that I should have. You know what they say? I should have gone through this like ages ago. Like, I should have learned this ages ago. This stuff is more important in general than getting your mesh shading working. When it comes to the overall of getting a nice engine. So it's just so people are aware, if they're watching, that it's not that you should do meshlets then you should learn how physically based rendering works. It should be the other way around. You should, because you want to be an overall good graphics / game engineer, game dev, engine dev, that's what I'm trying to say, than someone who's like really good at I don't know, mesh shading, but doesn't know, I don't know what would be considered beginner. I don't know what would, something like that, beginner stuff, right? Like they can't do a point light, but they can highly optimize meshlets. Because that means that if you're an indie dev, at least, you end up in a situation where you're highly deep in one area, but you don't have a breadth. And I've talked about this on stream. It's good, in my opinion, to have a good foundation before you go down into like more deep esoteric / more optimized or whatever fields within one thing. So it's good to have like a good base before you do that. No, I don't agree. I'm still not good in BRDF image-based lighting. I'm still checking the meaning of everything we write in shaders. But I'm still working on different topics like I would guess that Matt, you're exactly what I'm talking about. I believe you've already got the foundation. I'm kind of targeting this towards someone who's like, I've rendered my first model and I'm trying to get texture to work now. Should I start doing meshlets? Probably not. Get a general idea of what you want to do, and then you can go deep. I would guess, Matt, that you already have that foundation. Even though despite you're not that good at BRDF and image-based lighting and stuff like that. At least you know like kind of what you would be doing if you needed to do that. You need to look things up. It's not like you need to become a BRDF expert or a BSDF expert to then grow to then do meshlets. You can become special. I think, in my opinion, you would already have the foundation. Yeah. 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 I would just say, Matt, you're definitely an exception in that explanation. But again, feel free to disagree as well. I'm not always right. I don't mind being corrected. But for me personally, I want to make a little space game. So this is where it's important to think about what your goals are as well. I don't necessarily need advanced meshlets that occlude things very well, like extremely well or whatever. Due to the fact that my game is going to be quite simple, in my opinion, I would prefer it to have nicer lighting, and I think the only thing that I absolutely will need, no matter what, is view frustum culling for the individual meshes. Outside of that, like I might be able to get away with having no transparency at all, because of the game I'm trying to make. So I would say in my opinion, again, this is just an opinion, if you're making a game engine to make a game, let the game drive the technology that your game engine needs. Which in my case is I need to understand the lighting better to get kind of a more nice space feel than just one point light or in the scene, right? So that's what I'm doing here anyway. But again, if you want to become if you want to do meshlets, I'll 100% let you do that. Feel free to do your own thing. It's everyone's life after all. They can do what they want. But yeah, that's what I'm up to. Yeah, so that was a really good video. I think I'm gonna watch that again. Because there's so many things, and I'm like, oh, that's what that is. I didn't realize acceleration structures apply to stuff outside of ray tracing. I'm really excited to implement some of these. I've already implemented some of these in the past, like a pre-depth pass, batching, instancing. I've got at the moment occlusion culling. Oh no. Okay, so not occlusion culling. I've only ever done that, believe it or not, with meshlets. Never with actual meshes. So I don't have any I don't have any weight. I have no knowledge about how to build occlusion geometry. Yes, I don't have branchless shaders. I have done async compute, but for like just a test program. Obviously, you need a hierarchical depth buffer if you're going to do anything with occlusion culling when it comes to meshlets. But I didn't know about bitwise transparency. That's actually really clever, where you just blend the things together. This video is like so good. I obviously have bindless. I think everyone should have bindless. Shadow Atlas, never heard of that before, so I'm gonna like learn about all this stuff. Fantastic. So yes, let's adjust some audio so you guys don't get blasted by the music. About 42, 41 is about good, I think, for you guys. So can you can the pieces in the meshlets be different or the same? Yeah. Hi, Jetry Coats. I gotta love my YouTube. I've gotta love how my YouTube tab leaks memory. I'm fine. Does it? Oh, it forces me to restart. It's make the. Oh my goodness, that's terrible. Oh, I restart my computer for those type of reasons. Yeah, you don't usually touch individual meshlets. Usually kind of just run algorithms on them in specialized shaders. Anyway, so it's not like I'm... Okay, you got it with meshlets. Thank you. Awesome. You probably didn't appreciate the post. I recommend the took for granted. Let's see. I will. That'll be the maybe watch that tomorrow. You might have to remind me. Let's see. Took. I will. You know, I'll put it in my watch for later. Took for granted. Yeah, I hope you're doing well, D3, outside of your Firefox issue. Why the Fox engine is so... Okay, optimized. I'm just going to say optimized. Oh, okay, it's threat interactive video. Yeah, I can throw that in. I think I've already watched this a while ago. Let's how do I add this to a watch later thing? I'll I won't watch.
This is Metal Gear Solid V.
Yes. I won't watch this now. The guy who doesn't like temporal anti-aliasing, which is fair enough. I mean, no one has to like anything. Is there a save to watch later or something? There's usually like a watch later thing. Alright, I'll like it and then I'll be able to find it very easily. Okay. Alright, let's get back to it. So hopefully that's volume is all good for you guys. Let me know if it's not. I think that's good. Hopefully you're not getting blasted by the victory fanfare music. Okay, so let's close that. And let's get our this guy up. And let's have a look. Right. Where are we up to? Okay, so clearly what we're doing here is not working. I have a sneaking suspicion that I should be following this exactly. So what I'm going to do, I know this is likely doing some good stuff, but I'm going to test this thing for a minute and just kind of remove this. Not that it's a bad, by the way. I just want to see, because this, I've seen this before where it just does like this, right? I guess it doesn't really matter. And then specular times by diffuse equals times by illumination. I believe for a directional light is as simple as it gets. Yeah, I love his rage as well, to be honest. I'm glad you can appreciate it. Okay, so then I need to add in... What was I doing? I was messing around with something earlier. Base color. Yeah, when I watch Threat Interactive, I'm like, I want to get as good as this guy talks when you know what I mean. I don't know how good he is at programming when it comes to graphics, but I want to be that guy who just knows in depth everything he's talking about. So it's kind of like motivating. I find it's like a motivation thing. Where's the diffuse? Where? Okay, in the... Where? Okay, let's just check that things are working on a very basic level. Okay, so clearly the diffuse is not working at all. Yeah, that block needs extra nutrition. Indeed, indeed. Right, so we should... Right, I'm going to get rid of this, maybe? Right, so we should see diffuse, right? Okay, cool. So we've got Lambert diffusion. Okay. So the illumination, I think, is just too dark. Let's try... What was this on originally for? Okay, there we go. So we have our terrible lighting back, and we have basic diffuse lighting. Now, if I add the specular back in, how is that handling things? Right, so I'm going to apply this first, and then multiply. Make sure the multiplication is happened in that order. Okay, so looks decent, and we don't have that weirdness. Right, let's increase the brightness. Let's go to let's do double the brightness, because now we got specular. It's kind of darker. All right, so let's see, how's that looking? Okay, it looks okay. Let's okay, I'm gonna add, just make it 18. It's like more than double. Okay, so that might do for now. If I it still feels too dark. Let's increase the brightness to like... So I'm gonna like absolutely like spam this up. I miss getting my AMD 5770 HD and finally putting Half-Life 2 Gmod on X8 MSA. Yeah, I know what you mean. Those were the days we didn't know what we had. Yeah. I can appreciate that, dude. I know exactly what you're talking about. Okay. Let's turn off this for a minute. Let's see what else it looks like in general. Interesting, we got this like band. Doesn't look too bad. Doesn't look too bad. It's not, obviously the directions are all wrong, like I said, but we'll keep going with this. I think this is reasonable. It's got a bit bright around here. The contrast is a bit extreme, but I think I just need to bring up the overall, the ambient lighting. So I need to fake it by just making sure blacks never appear and just kind of increasing the I think it's the ambient strength, right, Matt? I don't know how to do that exactly. So what I'm going to do is just take the base color and just multiply it by a factor of like more than 1. Before the decode or after the decode is the question. So if I take this and RGB it, and then go Vec 3, let's do 1. This shouldn't do anything. So what I want to do is just make sure this doesn't do anything. So when I increase the brightness of the black, hopefully, like, so I don't know if that's going to increase that, you know what I mean, we don't get any. No, I think what I'm getting is just more intense colors. Okay. Okay, so the YouTube is repeating. Not that I don't mind the Final Fantasy X victory theme. So let's just pick a cool song. Let's go with... I don't know. Yeah, Hollow Bastion. Yeah, just increases saturation. What I'm trying to do is just get rid of the... I've done this before. It was just very easy to do, and I just forgotten how to do it. How do I increase the ambience here? So if I have a directional light, I need like give me a minute. If I look at my old shader for a minute, let's see, how would I have done this? Sorry, I'm being a bit quiet there. So what I'm looking for is basically, I want to get the overall darkness down. So I need to increase the dark. Need to increase the. Sorry, my phone is going off. Okay, so. Alright, so it's nothing. Nothing to worry about. Okay, so when I did this originally, what did I do? Because it was just like I did something with the base color and I can't remember what I did. Like it was after the light was worked on, we just had like all I did is just make it lighter somehow. So if it was like dark, I just did something. Increases saturation. Yeah, I'm not, this was not what I wanted to do, so if I do this, if I take... something like that, yeah, I'm trying to make this, good, yeah, just increases the contrast. Okay, let's do a dirty hack for now. I just want to make it a little nicer to look at. This is don't do this in real life. So I'm just going to test this with R. If this is closer to an epsilon, so if this is less than or equal to something like 0.001, then luminance R is equal to 0.1, something like that. Now this is going to make everything red on purpose. Yeah, don't do this. Yeah. But I'm doing this to make sure that, one, it covers all what I want, and two, okay, that's too light. So you're getting some tiny values. Yeah, I just want to increase the value a little bit. So when you see the when it's not completely black. All right, so let's try that. Let's try that. I know, again, please don't do this. This is terrible. I'm just hacking together some quick test, really. This is the opposite of making branchless shaders, by the way. Oh, that's not even a value. Yeah, so I'm just trying to bring up the absolute blacks. But this is the worst way of doing it possible. Yeah, let's try. You can add +1 to your. Oh, okay. Maybe that'll do it. Yeah, because that looks terrible. I'm not gonna lie. Yes, I have render doc. Branch fill shading, yeah, exactly. If you have, I'm going to show you a trick. Oh, cool. Let's see how this works first. Oh, look at that. Right, so let's get rid of this. And okay, so I'm going to look at a rock. I don't really know why it's banding like that. Yes, I'll open this up in render doc in a minute. If there's a trick, turn this off. Huh. Okay, it looks kind of cool, but it's a bit strange. Okay, I just need to improve my lighting skills. So let's let me before I okay, I will I'll do render doc in a minute. Can I give me like a minute so I can actually get it in render doc. So GPU. So I've just got to turn off my validation layers and stuff like that. I have them hard coded in, and I need to turn off my logging really as well, which just takes a minute. And I've got to also make it in release. Well, I put it in release anyway, just so the versions are different. And I'm also just going to copy over my shaders because they've been changing. And then we should be able to launch in render doc without an issue. So I'm just going to build, not run, because we don't have the shaders over there. So when I'm it's going to build. Nope, it's completely not what I want to do at all. So this is automatic for this folder, but not for the other two folders, which is probably a bad idea. But so I'm just going to grab all my shaders, and there we go. Yep, and then we should be able to launch release without any issue. Oh, and we also need to copy over the model. There's a new model that we have. And sorry I'm taking so long. It just take a minute to get the release build working. Just because most of the time it's just barely used. Shader, no, assets. So this will be here, this will be here. So throw this in here. Okay, so that should be that. Okay, that should run. Okay, that's running there. And if I go back to here. Yeah, okay. Let's get render doc open. So I'm not on administrator on this computer, so bear with me. Everyone close your eyes. Password 123. Oh, you need it. I need unoptimized shaders. Oh, sorry. Yep, I can do also a debug build. But this is the usual. That's also a chill. Let me launch. I don't think my shaders are optimized in any way, but I'll do a debug build once that's built. Give it a second. It's got to rebuild a lot of things when I remove the validation layers and printing and all that kind of stuff. All right, so launch. Oh, it doesn't have. Sorry, it's not going to work. I also need to copy over the new stuff to that folder. That will take less time though, because I can just go and grab out and. Oh no, we're just gonna paste over And the shaders, while that's doing that, replace. And because otherwise, if I don't do the shaders, you get weird issues, and you're like, why is everything broken? Nope, just copy. Build, debug, assets, shaders, paste, replace. Okay, so now we should have a working debug build. Let's just relaunch our application and launch. It's still not working? Let's try release. Give me a minute. I apologize for taking so long. Is it just in general or? Okay, right. Let's just do this lazily. Right, so we know where release works, and we're just going to copy over the whole asset file. I don't do this very often because it takes forever, but, well, it takes a minute. So yeah, once this is done, it'll work because now everything's working. Okay. Okay, finally. Let's close that. All right, launch. Capture a frame. I assume you want me to do. Okay, so I'm going to capture a frame and then read the chat. Okay, so find a decent position and take a screenshot. Then choose one of the draw calls to the pipeline. Choose fragment shader and click edit. Sure. So we've got a duck there, so let's mess around with the duck, eh? Oops, I need to actually open this. Okay, so our draw calls are... it's a lot more than I remember. Ah, well, that's why, because you got individual thingies. Anyway, so this is, if I go to texture viewer, let's just see what's what. So that's that. That's kind of boring. Yes, all these guys, which are awkward. So we'll do, how about that? We'll do the duck, right? You can attach as well. Oh, can you? From Visual Studio. Run Visual Studio, choose attach from running process. Oh, yeah. I thought you were talking about like render doc was able to capture. Okay, so let's go to choose pipeline, stage, go to fragment shader, and click edit. Where's the edit? Where edit? Okay. Yeah, we can edit the whoa. I see. Okay, so it's like a proper values in here. Alright. Wow. Choose the duck. I think I did. I'm on edit. Did I click the right thing? I decompiled the shaders. What? Can you change this stuff in like live or something? This is the duck there. This is I don't know if you saw. Sorry, I might have gone too quickly. How do I get out of this? Okay, so I went pipeline stage. There's the duck. Instance rendered draw call. Then I went fragment shader. Then I went edit. And there we go. This is what came up. So this is cool though. It's got oh wow, that's cool. It's got the index and the values. So put this into a different column so I can see the texture view. Like this texture view, right? Change the values and apply changes. Okay, let's what should we do? It's not that complicated. Just remove the lighting. Just something basic, and apply change. Oh wow, it changed. Oh my goodness. What? That's really cool. I mean, it was on the wrong side, but how true is this to... Let's bring this back. Can I control Z? So let's increase the brightness, right? By some crazy amount. Oh, okay, yeah. Jeez. That's really cool. There we go. Thank you. Thanks for that, Matt. That's something I'm going to play with in the future, I think. Delete that +1. Sounds good. That's my favorite song. Let's reduce this down a bit as well. It was a bit extreme. It's really cool. You know what we'll be able to do now? We'll be able to mess around with the ambience. See if we can get the ambience up. You just get like way faster feedback now. Okay, so if we change... what should we do? Your shaders are a bit optimized there, that's why like this, if you choose an optimized 0, you'll see the exact shader. Got you. I haven't chosen any optimization levels, but it makes sense that it doesn't look too bad. Let's see, what can I mess with? Relative intensity. I think you just changed both of our lives here, Matt. Yo. Lot, you should try Insight graphics. Yeah, Insight's sick. I used that a lot for the my frame rate went to 16. Truly it went to 16 frames per second, and I had to use Insight to figure out what was going on. Turns out I was too many. It was a lot of things like too many draw calls and stuff like that. So. Yeah, truly. I don't know how to use your tools very well, admittedly. Like I've had people in the live stream in the past being like, use RenderDoc. I'm like, it won't be helpful. No, it won't be helpful. Then I use RenderDoc and I like, oh, this was really helpful. So it's if I, what if I just like plus vec vec4, right? Okay, what if I do that? I'm kind of curious. Whoops, sorry, that was my Windows noise. Apply changes. Ooh, okay, probably went to white if I were to guess. Yeah, I'm gonna leave that there. No. But that's actually what I want, I think. Remove. So I obviously don't want to do a 1 plus vec 3 0.1. Gray. That's grey. Why is it grey? We're losing colour here. Oh, hang on. This is after the... lighting, so I think it's just bringing up the darkness after the fact. Oh, after the decode maybe? Vec 3 0.1. Can't tell. Let's increase that to 4. No, it just washes it out. Interesting. Since your app is still on, oops, sorry, I didn't read this. Since your app is still on, you can move in the app and get another capture and check what happens at a different angle. Yes, that is if I open up the do something like this, and then where's the capture frame button? Where's it gone? How do you, oh, do you press a key? F12? Ah, okay. Where, that's what I was looking for. Yes. So I'm going to try messing around again, because that was really useful, texture viewer. And because that's going to show both sides, which is nice. And what I'm going to do is just try and remember this. Pipeline stage, fragment shader, edit, and then throw this to the column, which is here. Bring up texture viewer, and then, okay, that's a lot easier to mess around with stuff, right? So what if I do, I know it seems funny, but like, what if I add it to the BRDF? Like just a random value across the whole thing. No, that's not going to work, is it? That's just going to calculate where the light is. Get rid of this. That looks terrible. Apply changes. Good. Okay, so... Let's add. Yes, avoid this thing. Yes, thank you. Thanks for all these tips, by the way. Yeah, Matt is. If you weren't here, Detricode, he's been helping me out with the general understanding of Fennel as well. So what I'm interested in now is to. So it's been a crazy stream. We've made so much progress so quickly because of things like that. So 0.2. It just grays it out. Interesting. Just makes everything lighter. No. Okay. If I add this to here, then maybe like 0.1. No, that just has this horrible line effect. Yeah, there's a guy in chat called Ratchet who's also very good at graphics programming. So yeah, let's keep going. Oh, did I adjusted the music, didn't I? Yes. I'll turn it back down to 40. Hopefully, usually it's about 40. 0.4. I think instead of faffing around with this, maybe I should just get back to studying and get better at like understanding what's going on. Not that this isn't fun. I think it would obviously look better if I did this, but I think having a better understanding of how light works in general is going to help me understand like how to increase ambient strength and do things like that, right? Worry about optimization when I'm better. You know, like a couple of days from now, I'll be able to understand what's going on. You're missing a couple of things in the illumination, in my opinion. I probably am, but I just don't know those things. You don't have to explain it, by the way, Matt. If you can, if you want. But what I don't know, I'll show you my biggest weakness when it comes to graphics in general. Isn't actually the BDF stuff. That's actually better than, despite it being very weak, it's very weak. Excuse me. The only ever light that I've ever done in graphics, for like the multiple, like maybe like 2 years that I've been messing around with meshlets and then doing other things, is lighting. I don't understand a lot of this stuff that you probably understand, and a lot of other people definitely understand. Like I don't know how. I understand like I've got better recently. Like I understand like light strength, but there's stuff in lighting that I don't quite understand. When it comes to like how it works. So I think it's gonna probably benefit me to get through this section, understand what's going on, because like obviously they don't have like horrible banding when the light, where the light isn't hit, right? So, and you know, just get better and better at this kind of stuff. Like that's what I think is probably going to be beneficial. I'm thinking like long term, like how to get better at this type of stuff as well, rather than just trying to fix individual parts right now. So I can level up as a developer and level up my engine at the same time, but it's going to take a little longer to do both. So that's what I'm going to hopefully do. So that's one of my weakest areas. It's just like how the geometry of light works, and how like light works in general. Outside of BRDF explicitly, I don't know how to calculate the light radiance. No, what is it called? Light, instant light radiance functions and stuff like that. So I'm not good at actual physics calculations. I'm just good at math I'm just a good math interpreter. Got you. Yeah, I'm probably I'm not good at I'm not good at anything. It almost feels like. All right, so we've got let's go through the diffuse at the very least, so I can understand this better, and then we can summarize the model, and then we can start to improve the BRDF, right? Make it better and understand the maths better, and get better at energy conservation, despite the geometry being light geometry being absolute poop. For our actual, when we're actually looking at the things like this, like forget the horrible streak down the duck and all that, but this part here, that we can get better at this. We can improve this part. We'll worry about like how shadow, like the dark side of models and stuff like that. As I get better at like lighting light, as I get better at like understanding like light geometry and stuff like that. So, so yeah, that's the goal anyway. Oh, are we getting oh no, we're getting that horrible synchronization bug again, I think. I don't know if that's just because of what we've been doing. Oh. That's not good. Okay, I've got it. Right, that might be because of this, right? I don't know if you saw it, but like the meshes start to pull apart sometimes in it over time. Yeah, duck tried to drink bleach. Yeah, it's not good. So what I'm gonna do is just let this compile. Well, I don't think it'll take that long, but I'm just gonna head to the loo while it compiles. So in my opinion, you need radiance values, which is the color X light intensity. Then the KD, which is fixed for outer radiance, which is 1 minus Fresnel times by 1 minus metallic to create outer radiance, which would be KD times by albedo divided by PI, which is specular, times by radiance times by LR. Okay, got you. Then you can add your output. Thank you. I'll write that down in a minute once I've gone to the loo. I have experience in physics calculations, my department would say that this is lighting and not our area of expertise. I see. Right. Yeah, yeah, I just need to get better in general, you know. So I can just not struggle with these things. Anyway, right, I'll just leave this compile. I'll put the BRB message back up. The professional streamer overlay that everyone loves, that no one has. Yeah, so I'm just gonna press that. Yeah, be right back. Okay, there we go. Right. Okie dokie. So, where are we up to? Oh, the probable synchronization bug, which is turning up again. What I'm gonna do is, for the time being, I probably won't see it. The only way to really trigger it, honestly, is I just saw it earlier. But I think it might have been due to the fact that we were doing a bunch of stuff with Docker. Render doc. I'm just gonna pray and just kind of move on. Right, let's get back into it. I can't like try and fix everything without. Okay, so the first thing I need to do is actually organize my notes because I've just finished the Fennel one. So we basically have just done the specular. So let's get the Fennel in. I think my graphics theory need yes. The Fennel. Wow. Thanks for that, Matt. You know what? Should we try it, guys? Should we try throwing that in to fix our terrible? Yeah, let's give that a shot because Matt's been helping out a lot. I do have AO, so I can do that. No shaders in chat, no. Just kidding. Yeah. So let's work backwards. V. So our LO is. Oh, we don't have KD. We don't have anything. So let's work backwards. Let's not work backwards. I am going to steal this from a. Hopefully, you don't mind me going into the chat like this. All right, let's grab. Oops. Let's not ban anyone. That's not what we want to do. Now you get to see behind the scenes of the shader, but I think it'll just take me forever to type. So this is probably worth it to grab stuff out. Matt has sent me a virus, probably no, a shader virus. Can you imagine? So LO, and then there we go. Fantastic. All right. Right. Obviously, we're going to make this look nice in a minute. But thank you, Matt. Let's just see what happens, right? So we have metalness, which is not metallic. We have roughness here. He has G. Okay, so we just need to change these names. So let's change these names, right? So I've called them something slightly different. We have distribution GGX. He's just used a... He uses camel case by the looks... I mean, is it snake case or camel case? I can't remember. Alright, so this times by that equals specular 3. I don't know why I've got no syntax highlighting. We have the KD, so we need metalness again. And why have we got no syntax highlighting? Oh, there we go. Okay. Probably a hidden character. You gotta be careful of those guys. So ambience. So do we have ambient light defined? Radiance. So we have LO. N.L is now NOL. Radiance is there. Light frame. So this would light color. This would be. Let's make it. Let's write our own color, right? Yours is camel. Mine's snake then. Color equals vec. No, it's vec4. Sorry. So I'm just going to write the variables that I'm missing straight in the shader, because if I don't, I'd rather just keep things simpler. So let's try white light for now, right? And we'll come back to changing the color. Oops. And 1.f. So light color RGB and .a. So albedo. My albedo is just base color. You can tell I've never worked in a graphics company before. Don't use the correct words. Just use base color. So we have specular. You have ambient. I do have AO, and I think it is called AO. Let's see. No, I don't. So I'm just going to remove AO. I know it's not that much of it. Ambient intensity. That's what I don't have. Pascal case. Okay, thank you, Detri. Yeah, we'll get there. So LO plus some ambience. So I literally don't have these AO, and I thought I did. Hang on, let me go back to my old shader. Where's AO? I commented out and I can't remember why. Did I name it as something else? My ambient occlusion, where has it gone? Alright, so I'll just simplify it a bit. The last parameter is for intensity for optimization reasons. I see. This will be frag color. And I'll just comment this out for a minute. And my terrible lighting. I'll just comment this out. So pi, I definitely have. Base color. So I'm going to say ambient is equal to this. This is probably not ideal, but we do have a mischief. Fantastic. And hang on. There we go. Okay, I don't know why I deleted that. That was a mistake. Let's go back again. Okay, no, that was it. Okay. Alright, so let's just have a look at how that goes. We're probably going to get a compilation error with a you didn't do this right, so I'm not surprised. 304. Oh, we fixed this, didn't we, for ourselves? Let's grab our version, because it is a bit weird. Oh, RGB, yeah, okay. And next is distribute DGX. No matching function for that. So I have just... Okay, so you probably use a different function then. So, or you're just using... I'm just... Okay, no, I don't think you are. You have just not dotted these together. Not that I don't think it matters. But it might be a completely different function, who knows. For now, we'll just roll with it and just say that the specular part is not. Okay, so no matching function for that either, and I think I've just dotted some things together as well. Yeah, NOV and N. So NOV. Oops, not caps. And N.L. Okay. Don't think. Yes, I have started the timer. Light color is undefined. What did I comment it out? Oops. Where's light color gone? Light color. Where did I put you? There it is. Let's cut this out. Obviously, this is a. You wouldn't do this because it's not changeable. And 314. Okay, so wrong operand. Thank you. I will give that a shot in a minute. If it looks the same. If it looks rubbish like the one I've done, then I'll change it to your one. Matt debugging my shaders live. The live stream. Now I appreciate yeah, for everyone who like I said before, no one's if you're having fun, then I hope you're enjoying the stream. No one has to participate, but oh, we don't have ambient light. I meant to get rid of this. We're just gonna have that for a minute, and this is RGB. PI plus specular, which is RGB again, and radiance. Okay. Okay, yeah, that's just a. Okay, let's have a look. I don't blame your shader, by the way, if it is rubbish. It's just ooh. It's probably my code. 99. Huh. It's like I think the AO and the ambient occlusion maybe reduced the color. So I had to come up with like a bunch of like hacks to get this to work. But anyway, let's go back to this is cool. Thank you for sharing. I just wanted to put it up for fun more than anything. I will kind of add this as a bonus. What I'm going to do is going to save this, right? I'm going to put it in like a different function, say like Matt's lighting, right? And it's just so I know not to delete it. Oh, the ambient needs to be times by 2. Okay, yep. So I'll put that back for a minute. Hopefully just having a random function there is fine for GLSL. It won't freak out. Oop. Okay, so it's just this. It doesn't understand what all these are. Yo, nice. Ah, I like the ambience. You pulled off the ambience properly. And I think my code is just butchering your lighting code. So I will, thank you. Actually, that's going to be really useful in a minute. In fact, I think that's going to fix our problem. Can I bear with me just a moment? Honestly, I really appreciate you, Matt. Giving me codes and stuff. It's kind of fun. So these don't exist. I'm gonna get rid of them. I think what I'm gonna do then is for this base color plus 0, times by 0.2 plus ambient. Now, obviously, we haven't done the LO here, but I'm kind of curious if I just do a plus base color RGB times by 0.2. 0.2, right? Multiply that together, so this obviously would be better as a variable. But if I put this here and then get rid of this 1. No, it's the other way around. It's the other way around, 100%. D is undefined. I think what I need to... I know what I needed to have done. Let's put Matt's code back again. I know what I need to have done to fix it. To fix Matt's code. My lighting is butchering his BRDF because... Very simple. My light intensity is way too high. Yeah, it's incredibly high. This should be like 4. I think that's dead simple to fix. And also get rid of this for a minute because I don't know why it's complaining. Yeah, I think that's... No, Something about this is like the intensity is too high, and I can probably figure it out if I give me a bit more time. But yeah, anyway, I just thought I cracked it then. You know what you mean? You're like you're doing a bit of coding, and you're like, oh, I should go back to what I'm doing. But all right, let's be a bit more disciplined now. It's my I've got to slap myself on my own wrist here. This will come later. There's the skills, and this will come later if I just give myself a bit of time. So let's get this compiling. Sorry, I wasn't around. Hi, Ratchet. How you doing, dude? Yeah, we've just been talking. We've just been debugging shaders for a bit, which has been a lot of fun. But okay, I need to go to this. Do I use this anyway? Yes. Okay, so dist. So there's a D somewhere that's being used, and it shouldn't be. Oh, there's a redefine. Oh my goodness, I'm leaving all this in here. Didn't mean to do that. Now Matt's function is down below, so we can remove that. Okay, so that was what's going on. Didn't realise. My bad. Okay, so yes, that fixed the issue. That fixed the issue. Now all I need to do is decrease the amount that's being added. So that fixed the issue, guys. Yeah, because if I just lower how much it's being multiplied by, we get darker side versus a lighter side. Yeah, so let's increase the intensity a bit. So sorry, I'm debugging this again. I should be studying really. Sorry about lack of. We're very close, so I'm getting quite excited. So I'm just going to reduce this again. Kind of increase the intensity, which I think was at 100 for a reason, because it was just so dark. So I'm going to go with like 75, so we don't get like horrible banding. Yeah, there we go. Look at that. True darkness is not true black anymore. It's dark, but it's like distinguishable. There we go. So if I turn off this, Like even here, you can kind of make it out from the black. That looks really nice. Thank you guys. Honestly, that's really helpful. Thankfully, we got a. Thanks, Matt. Thanks, Detri. We got it working in the end. Okay, so let's catch up with chat. I'm sorry you're on 2 hours of sleep, dude. Light colors alpha channel is your intensity, but stop fighting with your codes and do what you should do. You're right. Yes, I hope you don't get micro sleeps that jolt you. Oh, I hate that. Yeah. Could you push your BRDF changes once you're done today? I'd like to review it. Yeah, Ratchet's pretty sharp on the BRDF, so yes, I can push this up. Yeah, I don't see any reason why I can't. So remember, if anyone wants to check out my code, it's free. It's in on GitHub. It's in the description of the live stream under the Void GitHub. My name on there's Vertex F because I was obsessed with OpenGL at one point. Haven't changed it because it's kind of nostalgic. I was like, OpenGL is the coolest. Vertex F. It doesn't even have the 3 in, so it's not even a valid command. Yeah, backstory of Escape Point. When he was a wee young Vertex F. Anyway, right, let's get into this a bit more. So we wanted to take our notes, and now we've improved. So just for you're aware, Ratchet, my BRDF function is going to be extremely basic. I haven't actually made like too much headway through this through this filament thing because I had to work on a bunch of other stuff that broke the engine broke in different ways. Come on, there we go. So we fixed a bunch of stuff. We've been talking about other things as well. So if you do review my BRDF, you might be like, "Is that it? You've got a long way to go, Padawan." Yeah, you know what I mean. You might find other things that are a bit basic. Start the reboot. Oh, I appreciate that, man. Yeah, feel free to do anything with it as well. It won't run on your computer, just so you're aware. Just anyone who's watching this for the first time, because I'm not uploading the art assets to GitHub. So, yeah, it's pretty. I don't really see the because there's going to get more and more art assets out there, and eventually it's going to be not really. Right now I could get away with uploading the assets, but eventually it's not going to be practical. Light transport equation. Where are the other things I need to link? So these need to be linked. Put this in here. Linking all my notes together. Graphics theory. Put this in my BRDF thingy. I just assumed 3D would be too large. That'd be like me putting too but that was me putting too much value in opinions of others. I have no idea. It's just not good to put binary assets online anyway. Through GitHub, unless you've got like a link to something. I skipped straight to Vulkan when I realized it's all just learning. Yeah. Go for it, dude. Detri. Love it. But I'm not expecting multi-scatter approximation. Appreciate you, Ratchet. Yeah, we're not doing BSDF yet. Yet, I'd say. Like I'm going to do it. Anyway, let's bring up our filament thing and actually get through the diffuse part, which is going to be quite straightforward, I think. So we've technically already done this, and I've kind of understand this already, but it might as well be good to write it down. I'm not the person to ask with DirectX over Vulkan. I just haven't used it. Okay, so I'm going to read this now. In diffuse terms, f_m is a what? A Lambertian, right? Lambertian. Yeah, Lambertian function. And the diffuse term of the BRDF, Lambertian. All right. The diffuse term is a Lambertian. Look at me learning in real time. Had to learn a word. Had to say a word. Function, and the diffuse term of the BRDF becomes. So this is not including the specular part of the thing. f_d v, comma. Actually, I'm just going to copy the LaTeX. Hello, Maddo. Hi, how you doing, dude? Matt says nothing. You should always care about my opinions, mate. Yes, that's why I always believe what you say. Yeah, there, Ratchet. DirectX 12 also has become, they're kind of improving a lot altogether. Oh, nice. Buffer device address basically points to the GPU. Yeah, it's real sick. I prefer that to heaps. Well, at least in theory. I've never used heaps. So I'm just going to grab this. How you doing, Maddo, anyway? Hopefully you're having a great day, whatever you're up to. Hopefully Vulkan is treating you nicely. So, oh, what am I doing? I need to throw this in just completely. Alright, so f_, no, fd. We have frac pi 1 over, so n backslash c dot. I love this song, it's so good. Okay, so c dot in, and what was it? I didn't. Oh, so L. I can just look at that. C dot L. Okay, cool. So we've got the whole thingy after that. Very nice. Didn't have to write anything else. Our implementation uses a simple Lambertian BRDF that assumes that a uniform distribution. Yeah. Okay. So we are going to talk about the most basic Lambertian function that assumes that we have a uniform diffuse response over micro facets. Oh, you still on to scripted sets? Oh, good luck, man. It's a toughie if you've never done it for the first time. But you know, I believe if you're up to this point in Vulkan and graphics programming, which includes myself, by the way, that you're capable of understanding it without. It's not going to be easy, but you're definitely capable. It's one of them. It's Okay, so Okay. Angry face. On the most bleeding edge of DirectX, you index into bindless resources, descriptor heaps to access. Interesting. I see. So we're all moving to bindless effectively, as far as I reckon. You can't use pointers like you can in Vulkan. Yeah. Well, I think it's in general what you guys are talking about is like everyone's moving to. Everyone is moving to bindless no matter what, and it's just a matter of time. Why is it FD? That's the question. FD. Like bindless is the future, and we just got to get there one way or another. Oops. Return 1.f divided by pi. Now I've officially written this function. I'm allowed to actually make it my own. Void. So void main, just so I read this in the future and don't get confused. FD. I've definitely moved. I've moved from my non-bindless engine to a bindless engine over time. Oops. Why is it doing double? I don't know why it does that. FD Lambert. T. I missed a T there. Lambertian. Alright, so okay. Do you really need it though after DirectX enforces you to use pure bindless? Huh, interesting. Really? To make things bearable. There we go. Alright, Lambertian BRDF is obviously extremely efficient and delivers results close enough to the more complex models. Okay, so this gets us... Oh, sorry, this is efficient when it comes to delivering results close enough to more complex models. Yeah, well, if it works, Matt, then it's appropriate for what you need to do. You don't have to make the perfect thing work as long as it's appropriate. That is probably the most likely thing that's necessary. But anyway, however, the diffuse part would ideally be coherent with specular term and take that into account. So, however, the diffuse part would ideally... Okay, so, however... The diffuse part would ideally be coherent with the specular term and take into account surface roughness. Alright. Both Disney BRDF and Oren Naya, I don't know, model takes into account the roughness. Take the roughness into account and create some retro reflections at glazing angles. Wow. Okay, so the Disney diffuse BRDF and Oren Naya layouts are optional. Different pipeline layouts. They got deprecated by descriptor heats. I think there's a VK extension buffer also, which just lets us use buffers without pools. What is that? I can't actually remember what that one is. Morning, Mika. Hope you had a good night's sleep. All right. I'll let you guys continue on the talk. Just because I want to get through this, I am not as engaged as I was before, but I'm glad. Oh yeah, we can use Vulkan can use descriptor heaps. Well, it's a new one. I think it's But I do like I read descriptors are hard, this article that Ratchet sent me, and ever since then I've kind of like I like to access buffers via a pointer via buffer device addresses. Where's the music? Yes. Anyway, I'm sticking with Vulkan 1.2 bindless. Nice. Yeah, yeah, as Roger said, they're not well supported yet. Given our constraints, we decide that the runtime extra cost does not justify the slight increase in quality. This sophisticated model also renders image-based and spherical harmonics more difficult to express and implement. Oh, I see. So you can use better diffuse things. What is it? Diffuse BRDF. DF, than which improves the accuracy. Improves the accuracy of the what is it? The grazing angles. Yep. Grazing angles by retro reflections. However, IBL image based. I'm not actually sure if it's image based lighting and spherical harmonics based techniques are harder to implement. Okay, so I'm going to split this one to two. Disney's diffuse BRDF. Okay, so here is the Disney. Maybe get copyright strike if we use this by Disney. I had 2070 up to 6 months ago. I'd rather consider that mass someone of my mind. Someone of my mind. Lol. I decided to require RT for my renderer. Check if your card supports it. And nice. Yeah, that's the thing. Is anything that's least Turing has heaps. Don't worry, Detri. There you go. RTX 2060, I guess, is that limited. I think Turing Plus support is fair. A lot of people still on the 20 series graphics cards, yeah, that are gonna get sub 30 FPS with actual ray tracing. Just something to consider. Huh. I wonder what mine would do. I mean, I got a 4070. I think it would be okay with your renderer. It'd be sad if I couldn't get it working. I haven't actually tried, so anyway. BRDF expressed like this. Just wanna yeah, it is one of these things. I was thinking about meshlets in the same way as you guys are thinking about ray tracing. It's like, how far back do I want to cut people off? And oh, I don't know how to type this out. Oops, I did it again. I was like, oh, do I really want to have to support like a different code path for people who don't have Turing architecture hardware or above? F_D frac sigma blah, 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 schlick. So this would be F schlick. F_schlick. Alright. Yep. Grab that. And we see this again. And F grazing is 90 degrees. I see. This is why we had this earlier. Okay, so I'm gonna. The music's, I think, repeated. Let me just fix that again. I think we've heard this before. So there's nothing wrong with this song. It's just I don't want your ears and my ears getting tired. Yeah, let's go through. Okay, so I'm just going to let that run. And then we'll listen to some Unreal Tournament type music in a minute. Wow, is it really that bad on the 2070? Wow, I didn't realize it was that bad. Okay. I guess that's why people dislike ray tracing, because it mustn't be fast enough. I don't know. For older hardware, or people try to do too much with it too early, and they should have just done shadow rays or something like that, like something simpler. That wasn't going to cost the whole throw out the baby with the bathwater type still, you know what I'm saying? Because it, it kind of sucks when you can't get it to work. So, theta. Underscore D. Don't know what D means, but here we are. Yeah. RT is not my thing. I hate it so bad. It's so lazy. It's so lazy work, in my opinion. People are moving towards RT light tracing because it's easier to control. Yeah, 2000 was fair enough. Yeah, I'd be interested to see how it performs. I wonder how you would think about this. I always thought, like, in the future, hypothetically, I don't know if this is true. This could be just me just wondering. Like, let's just say like 100 years in the future. Do you think we'll be fully on path tracing by that point? I was thinking about this earlier. I was like, well, with because I was briefly learning how to do offline path tracing by accident. Long story. That was like literally two days ago though. And I was like, wait a minute, this is cool, but it's like I wonder in the future will we just be able to just like plow through enough samples per pixel that we can just get perfect lighting. Oh my goodness. So 2000 series were terrible. Good to know. It's good to know because if I ever use path tracing in the future, sorry, ray tracing, I've got to consider that people who are on the 20 series graphics cards are going to have a rough time. If I use it extensively. But anyway, it is what it is. Like Matt, I'm trying to do it. I'm trying to do the non-lazy way. I don't know if I call it that. Trying to do air quotes the good way, so other people could actually, run the game. Well, we'll see. I might end up adding ray tracing for limited things, like Ratchet does with his. He does some shadows. If you don't know, he's probably told you maybe. With ray tracing, but with a shadow rays, right? Which is kind of cool. Oh yeah, I'm never going to use stochastic either. Yeah. So replace 2B AI with shoddily upscaled lol. Yeah, exactly. Float, light, scatter equals slick. Whoops. Yeah, I'm probably not going to do this. What is suggest? Well, I'm going to stick with Lambert's. Float, view, scatter, vanilla slick. All right. NOV .0.1. No. It would be interesting to implement this though, but I don't know how to get the F90 in here really. Don't know what that would be. Oh, it's literally right there. I'd have to simplify that cosine so I get rid of the theta angle and kind of use a trig. View scatter multiplied by 1.0 over pi. I don't know. Escape Point mentioned you shared with him something about descriptor sets. Oh yeah. Are you talking about the? Yes, there is something on descriptor sets. That was a bit in depth. That's like what's good types of descriptor sets. Yes, I appreciate that, Ratchet. Thank you for sharing it again. For people. I don't think tracing is a good way to do rendering, not because it's shit or something like that. It's because it's F's the idea of playing video games like Minecraft, but I see, yeah, I see. So it's just used wrong, yeah. That's fair enough, yeah. It's more of a gimmick right now. I would say, maybe you're saying there, Matt. I don't believe relying on ray tracing or path tracing is logical. There's multiple good ways to improve your rendering and still get good results. Yeah, pretty much. I can see that. For me, it's just I don't know enough to even say what is good or bad yet. You know what I mean? Like, I don't want to be like, actually, you could do this, or anything, because I'm stuck on this. Like, what is Lambert diffuse? So anyway, figure 12 shows the comparison between Lambert's diffuse and the higher quality Disney diffuse, using a full rough dielectric material for comparison. For comparison purposes, the right sphere was mirrored. Okay, the surface is very similar with both BRDF, but with Disney one exhibits some nice retro reflections at the glazing angle. So, yeah, okay, fair enough. I will just kind of snip that. No, we can throw it in. Actually, I think it actually fits quite nicely in this. Here's an example. The second one is Disney's, and then you have nice grazing shadows on your sphere, which is good. We could allow artists / developers to choose the Disney diffuse BRDF depending on the quality they desire and perform on the target device. It is important to note that the Disney diffuse BRDF is not energy conserving as expressed here. Okay, the Disney diffuse BRDF is not energy conserving. Yeah, I definitely was talking about ray tracing global illumination. Thanks for the correction there, Ratchet. People think ray tracing and think Unreal Engine 6 slop, do they? Okay. Something projected flatly on the screen and fakes various stages of how close it gets to reality. Right, fair enough. Yeah, I can see that there, Matt. Ray tracing just feels like a compute shader with an extra steps and so. Anyway, okay, so we have the diffuse done. Hooray! Let's go. I did what I consider the bare minimum. Despite, I mean, a bit mean there. We did do a bunch of other stuff, which was nice. Because we fixed about 3 engine issues that I had based on trying to load a specular image. So yeah, we are all progressing in the right direction here. Basic, so Lambert diffuse, Lambertian. Is it Lambertian or is it all Lambertian diffuse? Hang on. I think Lambertian diffuse is. Give me a second. Let me just read this again. Lambertian diffuse function is a no. Okay, so Lambertian diffuse is just a regular diffuse. Okay. At the very least, despite people's reservations about ray tracing, at least you're not trying to sarcastically generate images with AI. At least that's got to be even worse than ray tracing. Okay. Right. Let's. I guess heavily dependent on drivers, right? I guess so. Yeah, after seeing how mesh shaders work for the first time, I thought that's geometry shaders had a baby with a compute shader, pretty much. Yeah. I've never actually touched geometry shaders. I'm kind of glad, to be honest, because it seems like BRDF, physically based rendering. So I'm going to take my specular, I think, and throw them in here and kind of not link diffuse back out to everything apart from the... they're all kind of related. Let's link them all up. It's not that bad. Lambert diffuse, and we need D, I think. Let's do Le Fennel. Fennelian. Okay, cool. And yeah, I'm glad I sidestepped geometry shaders. Mesh shaders are super sick though. I just if I had more time in the day, I would do a lot. Well, I do have a lot of time in the day technically, but man, I feel like there's like 20,000 things I need to learn effectively. That's what I'm trying to say. So I'm just connecting all my guys together. Fresnel. It's like so many things to learn in graphics. And we want our source node here, the filament material section. Fantastic. All right, so let's take this, put it in the graphics theory list. Oh, really? You use a lot of geometry shaders for... Wow, I wonder what you used it for. Plus 100. There you go. All right. Let's keep going. Right. We need to keep on keeping on. Okay, so I think this is just going to be me reading this. Okay, so summary model. Specular term cook. Oh, did I not even have the... I haven't actually written this out, have I? Let me go to my shader. Okay, so Ratchet, you're probably going to have to put up with my horrendous lighting, by the way. Lighting geometry. Oh, no. Diffuse. Lambert. When you actually look at this in the future, just so you're aware. Where we actually have some not absolute trash. Thanks to a lot of people in chat helping me out, by the way. Can't take all the credit at all. Where is the... This is what I want to do. Diffuse. And then we want to take... Now I'm kind of curious because you had a division by this, which I kind of want to throw in. What are you complaining about? F is undefined. No, it's not. We had this earlier, but it just... The ambience was the issue, not what I had. Pi is equal to 3, yeah. Whoa, interesting. I think the ambience is extremely high. Well, the intensity needs to be turned down tons. know, we get this horrible banding. I don't quite understand this division by... Sorry, Matt, I don't quite get this division. It might be the visibility function, actually. I think we might be doing it twice. If I look at my... It looks similar to something. Yeah, I don't think I can do this division. Either my code is just completely shoddy, which is extremely likely. But I'll come back to that. I've got your code at least. Imagine all the view frustum culling that happens in a task shader. Oh yeah, it's 10 out of 10. Funny thing is, in many cases, it's faster to do compute plus mesh instead of task. It depends on the geometry, right? Do you have a good Vulkan website to follow? Yes. Good question. Do you have a good website to follow? We're starting to learn Vulkan. I assume that you're going to have some C++ skills already, or some kind of like good background. But I will provide you with what I've been recommending to people. Let's get it up. How to Vulkan is probably my go-to recommendation. At the moment, it's the shorter tutorial out of the two that you could pick. One being Vulkan Guide. This is a very it goes through the concepts pretty quickly, but its point is to get you to a non-trivial application. It's still going to be tough to learn, but you know, if you take your time and take notes and stuff, this is where I would go, right? So I'll link this in the chat for you. Where's my live stream at? There it is. So this is a great tutorial to follow, in my opinion. So there you go. Just not game dev. Oh, you'll be absolutely fine then. You'll blast through how to Vulkan. And if you've got some experience, maybe consider... this one's a bit more... It's called Vulkan Guide. But I would say at least start with how to Vulkan, and then feel like if you want to do it, this is a bit more in depth. There's a bit more going on here. Because it has stuff like dealing with compute shaders at the same time as rendering. Like pretty much straight on. It has like how to set up IMGUI. All those. It's got a bit more in there. It's got like a bit more meat. But this is also extremely good. It's just I think it's a great tutorial to start with to see if you even want to use Vulkan. You know what I mean? Like if you've got 10 years of experience there, you'll be able to blast through either. Honestly. So yeah, there you go. Yeah, no problem. Thanks for joining us in the stream, by the way. It's for microfacet deviation. It's coming from the specular. BRDF minus specular. Oh, right. Okay, so I've done the maths different then. Right. That it did look similar. It looked like the visibility function. Okay, that makes sense. That's why it looks terrible when I do it. Not because you've done anything bad at all. It's because I'm doing this twice. I think, where is it? It's I think my visibility function will be different from your visibility function. And there's some kind of like algebra that I'm doing twice effectively. Watched a few times, but now never engaged with the stream chat normally. Haha. Appreciate you chatting. I'm glad you've been enjoying the streams, that you've been coming back. Appreciate it, my man. All right, so let's keep on going. So we have got to the standard model. I'm just going to read through this quickly. Standard model, specular term, Cook torrents, specular microfacet model with GDX, normal distribution function, and the Smith GDX high correlated visibility function, and a slick funnel function. A diffuse term, Lambertian diffuse model. The full GLSL implementation is going to be here. Okay, so mine's basically the same, by the way. It's not like it's just got a little difference. It's just I work out through Matt's help in the chat. He's helped me work out what F0 is. I used basically the same visibility function to I don't normalize manually. I see, yeah. I usually follow Unreal 4's BRDF. I have the paper for that. Okay, that's a good one. I think that's why it's not like we're doing anything. I think both of us are doing like the thing correctly, if that makes sense. But I have just I haven't made a note for this. Hang on. I haven't done the Disney one. Just make sure I haven't included that. I have. Whoops. Okay, so these should be separate. Just to make the note a bit more parsable and approachable. So, I need to make my notes title first. And do this, add that. And graphics theory. Let's get some water. I'll have to look into the Unreal 4's BRDF. I see. So it makes total sense. So you've got 4 times by n dots v multiplied by n dot l. I think in this version of the BRDF, it does algebra. It does some algebra that it kind of excludes. Like it has that there, right? But based on that, it does some algebra to down here. It does some algebra to exclude it with like 2 visibility functions that basically exclude that term, and we get like a different function, and then we derive from that, and we derive a function from that, and we get this based on the microfacet height. I think Unreal 4 does not use the improved height correlated version that Filament does. I see. Okay, yeah. So it has this like extra bit of stuff in it. I don't know. I don't know what's better, what's worse at the moment. Not good enough to know. So I have no opinion. I don't know why. I have no mouth and I must scream. It's like I have no opinion and I must judge. I don't know why that came to my mind. Nah, it's all chill. Right, get that in there. Connect these up together. So at the Disney's BRDF, I think that's just going to be thrown in as a thing like this. Just kind of like a small reference to this. And this is filament. Filament is neat, yeah, 100%. Ah, filament is new, I see. Hi, Matt. We got 2 Matts in the chat. Yeah, you can get a link for this, of course. Let me get it to you. Let me link you to. So I'm just going to link you to what's maybe the interesting part for you, which would be the. Where is it? Where's? Okay, yeah, material system. That's actually what I wanted. It's actually already in the URL. There you go, my man. That'll take you to chapter 4, which is where all the this is the stuff I'm reading right now. Okay, let's keep on. I hate to admit it that I tend to like Google C++ rendering document project filament graphite. Oh, interesting. Yeah. It is good, yeah. It's so far anyway. It's really good explaining stuff at least. Anyway, let's see what's after this. So we've got improving BRDF, which was my goal to get to at least this point, which is good. So we actually at least got this far. How are you doing, Matt? By the way, the one who's just turned up into the chat. I hope you're having a great day, man. Have you been learning cool stuff like you usually do? All right. So graphite is harder to find, but it's akin to Sky on Google Code. I see. Unreal Oren's Naya solution is bad, and the rest is pretty good. I like how Unreal 4 looks, but 5. Yeah, I have to agree with that there, Matt. I'm not a fan of how Unreal Engine 5 decided to do its lighting for some reason. Anyway, it's a whole thing. I used to think that it was temporal anti-aliasing that was like the issue, and why I didn't like Unreal Engine's like look, but it's actually just the way it did the lighting. Anyway, we mentioned in section 4.3 that the energy conservation is one of the key components of a good BRDF. Unfortunately, BRDFs explored previously suffers from 2 problems. Okay, so problems when it comes to energy conservation. Oh. Okay. Let's get some more water. Cool. Which is energy gain in diffuse reflectance. And the Lambert diffuse BRDF does not account for light that reflects on the surface, and that is therefore does not reflect on the surface, and therefore does not participate in a diffuse scattering event. I see. So, unfortunately, we got to talk about issues with reflectance plus diffuse. So with diffuse BRDF, might have to come back to this to see if this ever gets updated. Does not account for the light that reflects at the surface, that is therefore not able to participate. Let's copy that word. In the diffuse scattering event. Okay. Oh, thanks. Yeah, just went to my mum's birthday party. Oh, cool. Nice. Hopefully you have fun. Currently trying to figure out how to dissect data into basic functions and link back to something testable. What's a basis function? Never mind, I Google it. Is that something I brought up? Basis function. Anyway. Yeah, I sometimes feel like that, like I haven't Googled enough. Okay, so energy loss in specular reflectance. Okay, so the Cook Torrance BRDF we presented earlier attempts to model several events at the microfacet level, but does not at microfacet level, but does so by accounting for a single bounce of light. This approximation can cause a lot of energy, a loss of energy at high roughness. The surface is not energy preserving. I see. What's a oh, sorry, I read that twice. Think of it like a Lego function. Think a bit of Legos. Think of it like Lego. Sorry, maybe it's getting too hot. Flipping heck. Ugh. Think of it like Legos of functions that build onto more complex functions. I see. There we go. This approximation can suffer from high, and this can cause a loss of energy at high roughness. The surface is not energy preserving. Okay. This is why this loss of energy occurs. Okay, so when doing the specular part of the BRDF with the cook torrent version, we are only accounting for a single light bounce. This means that for high roughness there's just input and output and a tree of functions in between. I see, okay. Is that for FP? One thing I borrowed from HLSL is the saturation function. Yes, we learned about that earlier, didn't we? The Matt who was helping me out with the shaders. I had to like learn that that's the clamp over 1 over 0, 1 and 0, or 0 and 1. Yeah, it's. I am aware that I just need to. I also need maybe write my own saturate function because it's so convenient to look at HLSO code and just be immediately able to move along to the next thing. So high roughness means that that a ray might bounce more than once. This is why loss of energy occurs. A single bounce or scatter of light. Okay, so and be reflected out. Clamp pad saturate, good. Monkey saw, monkey loved, yes. Yeah, that's probably a really good smart move. I probably just need to also do the same thing with saturate. Yeah, just need to put that in, include like a global include, and there, Bob's your uncle. Okay, reflected out. Thus discarded because of masking and shadowing. Yes. If we, however, account for multiple bounces, multi-scattering, the same ray of light may escape. If we account for multi-scattering, the same ray of light might escape. And reflect back to the viewer, maybe. This is single scatter versus multi scatter. Right, cool. But I'm thinking about writing my own saturate because I don't like getting 0. Yeah. Like I've done. Like you've taught me how to. Maybe that's a good idea, actually. Yeah, maybe I should. I'm excited to keep learning. It's awesome. Anyway, based on a simple explanation, you can intuitively deduce that the rougher the surface is, the higher chance that the surface that the energy gets lost. And the failure to account for multiple scattering events. This loss of energy appears to darken rough materials. Metallic surfaces are particularly affected because of all the reflectance is all the reflectance is specular. The darkening effect is illustrated with multi-scattering energy preserving can be achieved. Interesting. Okay, so this is worse for metals. Metallic surfaces as Metallica. This is worse for metallic surfaces because as you should. Why is Final Fantasy 7 music here? Right. For some reason, what is it called? Square Enix does not want you to play Final Fantasy 7 music. All of a sudden. Let's go with I don't know. Let's pick something random. Yeah, nature. Summer's Crescendo. Anyway, pretty sure that'll break a lot of code. That relies on all behavior. It's making the clamp way pointy, in my opinion. So I should re-optimize things according to my changes. Interesting. I didn't realize. Yeah, I think it's because the Final Fantasy. I think Final Fantasy 6 is fine, but I don't know. I think it's because the new release is coming out. They've gone a bit tighter on Final Fantasy 7 stuff. You know, it should be okay. It's not like the end of the world. Gotta go. See ya. See you, Matt. Have a good rest of the day, whatever you're up to. Good luck with your functions. Was it discrete functions? Basis functions. Yes. I hope they go well for you. Okay, so the worst. The light is purely reflective. What? Light. So you will get darker. You will get darker rough metals with this approach. Okay. Here we have energy loss version. Here we are preserving multi scattering. Fantastic. Yeah. Mad. Interesting. We can white furnace. A uniform light environment. Set to pure white to validate the energy Preservation property. Preservation property. Ugh. To validate the energy's preservation. Oh my goodness. Preservation property of the BRDF. Okay. When energy preservation is achieved, a purely reflective metal surface Fresnel index equals 1 should be indistinguishable from the background. No matter the roughness said of the surface. Figure 15 shows only no MSVC is cooked. Yeah. Oh, you're like me. You're using MSVC. Yeah. Unfortunately, MSVC is behind. Ratchet, what do you use? You use Clang, right? On Windows? Okay, so when should be indistinguishable from the background, no matter the roughness of the surface. Figure 15 shows what such surface looks like with the specular BRDF presented in the previous section. The energy loss of the roughness increases obvious in contrast. Shows that according to multi-scattering events, addresses the energy loss. Right. Cool. Right, so what is that word? Hang on. My reading's getting worse. Yeah, it's furnace. Okay. Yeah, use Clang. It's always the yes, I thought so. Clang is beautiful, but I'm too afraid to switch due to Windows H support. Okay. Ent has a tool for compile time. Inference. If you're curious, you could use them without the ECS. Yeah. Looks like there's many ways around it. I've never actually needed... I've never come into a problem where I thought, wow, reflection is going to solve this. I guess I just write code differently. Not that it's not useful. Reflection. Excuse me. Pardon me. So lighting environments. Set to pure white. To validate the energy. Okay. Energy preservation. Okay, property. So property of a BRDF. Okay, so what I'm going to say is like how... Okay. Do we actually do anything with this? Hang on. Okay, so there's a bunch of theory here, but let's add this to our kind of like how to preserve energy. For specular lights. I'm using the runtime reflector for editor purposes. Yes. Saving, loading things, escape point. That's okay. That's how you use it. Give me... yeah, go for it, Matt. Good luck with your travels on that. Changing to Clang. Okay, so I just need to understand lighting first before I do this. I use it, but I'm looking for a non-registered runtime solution actually. Ah, okay. Okay, so the BRDF, blah blah blah. Pure reflective metals. Okay, so when you do this, pure reflective metals are indistinguishable able from the background. No matter the roughness said of the said surface. Okay, so figure 15. I'm just going to throw this in and just kind of put it underneath. This shows what a surface looks like with specular BRDF presented in the... Right, I'm just going to say in... I'm probably going to rename this. Energy issues with Cook torrents BRDF. You'll suddenly want reflection once you have to save. You have to save a file to handle. Okay. Yes, I probably will. We will. You want reflection once you write about very a dynamic modular editor. Yeah, it's worth the memory for fun. I got you guys. Thank you. Actually, yeah. Like I said, I've never got to that point. I don't know what like saving would actually entail when it comes to games. For me at the moment, that is like, it's going to be important obviously, but like right now, like we need at least a game to worry about saving. That being said, I probably will end up using Reflection if you guys are using it. Maybe even going to Clang. Yeah, 100%. Yeah. I understand that tree. Yep. No, it's appreciated. Honestly, you guys like teach me stuff like that. So it's like I said, I just never needed it yet. I just haven't know. I don't even know the problems it's trying to solve. To be honest, I'm like, okay, I get it. Yeah, runtime type information, all that kind of stuff. Got you. Anyway, go to Clang anyway. It's good. You might be wise on that one. I can't do it right now, but. Paint user good error messages. What do you mean? I love it when I get template errors and messages I can't understand. It makes me a better programmer. Okay, so multi-ball scatter micro facets BRDFs are disgusting, gross, in depth, Alright, I'm gonna grab this actually. Oh. Hertz 16. And he's referenced this multiple times. Oh, okay, yeah. No, he hasn't. SIGGRAPH 2016. Can I read this, or you can view the full content in the alright, so I'm just going to link this. Hopefully I don't want to download a file, but so when you're doing a link, you need to do like this, or hyperlink. Oh no, it's the other way around. I always forget. What should we call this? In height, what is the name? Hertz 2016. Nope, okay. Oh. It's one of these two. It's either a brackets. I keep forgetting the markup for this. What? What's happened? Oh, I must have deleted it? I don't know. Work. Hyperlink. Okay, maybe I just got it wrong. Hang on. Let's try again. Escape point tries for 4 hours to get a link to work. Come on. You got it. Oh, okay. Wrong way around again. This is so confusing. Okay, so hopefully, yes. Okay, got it. LLVM IR is arguably more readable than assembly. I wonder how many warnings and errors I will get after moving to Clang on Windows. MSVC isn't the most standard compliant compiler, so a good amount. Yeah, when I moved to when I compile on GCC on Linux, I often get like compilation errors. Not just warnings, but like actual errors that just for some reason MSVC just decides to allow you to do. Okay. Okay, so unfortunately this paper only presents a stochastic evaluation. Okay. Sadly, this only uses a stochastic, only presents a stochastic evaluation of multi-scattering BRDF. MSVC bad PR for C++. Yeah, it makes sense. MSVC isn't the MSVC is the world's first vibe coded compiler, but they did it before vibe coding existed. Ah, that's funny. That. Oh my goodness. Yeah, literally. Oh my. Well, here's the thing. I actually worked with MSVC's compiler from 2013 for 6 years straight. Now that compiler is horrendous. It makes the one I'm using right now feel like a dream. Like when honestly, it's you don't want to know the craziness that compiler lets you get away with. This solution is therefore not suitable for real-time rendering. Ah, I see. Therefore, this is not suitable for real time rendering. Kulia and Conti. Oops. Okay, I spelled that really wrong, didn't I? Yeah, it's tough, isn't it? Those older compilers, man. In their idea. Okay, let's actually get this one then, because the one they used is let it just load. Oh, there it is. Right, so this 2017 Christop seems better anyway, so be right back. Yep, no problem, Matt. See you in a minute. Fantastic, hell yeah. This is better. Alright, so how did I do this? Whoops. Okay, so the text I want to put in is... So I actually might read this, or get like a screen reader too or something when I'm like chilling. Alright. Their idea is to add an energy compensation. Compensation term to as an additional BRDF lobe shown in this equation. Alright, so let's get this fella in. Wait, this is Final Fantasy VII again. This is like, it's literally one of my favorite songs as well. Dang. Okay. Let's go through the Wagwan Midnight Tune stuff. Okay, let's bring this back up. Oops, I keep doing that. It's the LaTeX one, or the tech one. Avoids me having to type out all this. Ah, perfect, flippin' heck. None of it was, none of it needed correcting. Let's just look at it. So what's E and F? Are they expected values and variance? Oh no, okay, it's completely different to that kind of stuff. We're not working out expected values of Monte Carlos anymore, thank goodness for that. Though it's something I'm going to have to revise now. I can't get away from it now I've learned about it. E is the directional albedo of the specular BRDF. So, okay, so it's the directional, the cosine weighted, and then what's this one? The cosine weighted of the finale. E and E average can be pre-computed and stored in a lookup table, while F average can be greatly simplified when select approximation is used. Okay, let me think about this for a minute. I don't quite understand this. Okay, so what have we got here? Let's type this out. FR. When I've used F_R, that usually means with set to 1. Oh, okay, so that's set to 1 for albedo. A directional albedo of this. Oh, hang on. This is the thing I learned about yesterday, isn't it? This is the, not this one. It's the first one I learned. It's the normal distribution, right? In a normal distribution function, long tail is better fit for the GDX distribution, with long tail fall off, short peaks in highlights, with a simple formula, let's say equation, suitable for real-time implementations. The popular model is the Trowbridge-Wirtz distribution. So E is the directional albedo. It's the albedo now. This is what is this? Hang on. What is the specular albedo? Directional. I'm just going to Google this for a minute because I don't quite know. Let's close this. Let's get rid of these two as well. Just so we got some bit of space. Okay, let's go to Wikipedia. Bidirectional function, and we are interested in the. Obviously, it's not going to pop up. Sorry, it's my Windows noise, not yours. Directional albedo I'm looking for. Does anyone know why it's called albedo? Is it like someone's name? Do you think? Like why is the base color called albedo of the textures? So okay, let's work backwards then. Not that. Okay, E is the directional albedo. So I'm just going to look for this in the documents again. No, okay. Of the specular BRDF. I think what this is the colour. As far as I can tell, if I've polished metal, like polished gold, then it's going to be a gold albedo. And that's what the reflection colour is going to be. Is that from Latin? I'm not sure actually, Mika. It might be actually. Do you know a bit of Latin? Actually, I have no idea. I just thought it was after someone's name, but it could. It's not what I thought of at all. Yeah, it could be. Okay, so which I believe is the color of the specular light reflected back. Okay. Pretty sure albedo is the term for how much light is reflected off a surface in non-graphics context. Okay. Right. Makes sense. That would make sense, like what albedo is. Good to know. Right, so let's grab the LaTeX. Okay, so it's gonna have some errors in for sure. Well, not many though. So C dot V, and we have N. Okay, so the terms, there's a lot of integrals in this. I wonder how efficient it is to do this type of thing. E underscore average. Oops. Is the cosine... Yeah, because it's over the whole hemisphere, this one. The one above. Ah, come on. Where's the W? There it is. Weighted average. Planets have albedo. Okay. Maybe that's it then. Something to do with like planets or something. As well as how much light is reflected or something. Of E. I see. Okay, so that makes a little bit more sense. There's the cosine version. Right. Okay. So let's grab the LaTeX and throw that in there. N.L n slash c dot, and this is V. Okay, so finally we need similar. I know I'm typing this out like 1-to-1, but it's actually kind of important that I get this all 1-to-1 here, because this is kind of, it's not particularly bad. It's just I just don't want to get it wrong at all. The cosine weighted average of the fenil, which I don't want to spell with the wrong way around, term. Okay, cool. Okay, so get the LaTeX. Throw that into our, whatever it's called, this thing. Okay. What have we got then? Okay, so what I'm going to do briefly is I'm going to rerun this again. I'm going to keep this here just kind of like reference, right? No, I'll put this, where should I put this? I kind of want to move this out of here because it's going to be my source tree. Let's get rid of this. Let's get rid of this. Just going to clean up stuff for a minute. Specular BRDF. Let's get rid of that space there. And sounds good. Only here to turn off lighting if I need it. Okay, dokie. Right. Right, so what I'm going to do then is, despite having half implemented things in the deletion, yeah, there's a bunch of stuff I don't want to commit yet. I mean, it's not bad or anything, it's just like half finished entity management code. That's not the end of the world, I guess. So let's just look at what our engine looks like. Sorry, our lighting. So it's got a lot darker. But we don't have complete darkness on this side, despite it looking like that, which is good. And it's lit from this side, and we have the specular highlights that's in this particular model. That's why it's shimmering, which is quite nice. It's still quite dark, so I might turn off the intensity, which for the directional light. what I'm going to do is I'm going to commit one file, I think, and kind of call it there with the committing. So if I get... Where's the intensity gone? Yeah, so I'm going to increase the intensity by... Let's bring it to 10, right? Not 19. Just want to make it less dark. Yeah, so that looks better, doesn't it? Better than it did. Actually see stuff. And if I have more lights going on, got a lot of specular here. All right, so I'm gonna commit this file for people who are interested in looking at the individual file. So I just need to get the location at which that is. I'm going to move on with my day. I need to go to the office today. I have a good rest of the day. Thank you, Mika, for joining us. Yes, I hope you have a good work day. Thank you for checking us out. So status. So what I'm going to do is just commit one file. Not the whole thing. Jeez, no need to type that out. Git commits a new BRDF based. So a new cook torrents BRDF physically based renderer fragment shader, I guess. Lighting is still a work in progress. Okay, push. There you go, Ratchet. The shader that you want to be interested in is the new core shader new.frag. So yeah, I'm going to call it here, guys. I'm going to share my server with you as well. If you are interested in joining us in our little community, feel free to join us. I'll send that in right now, so you don't have to leave us. So yes, thank you for all your lovely comments. Thank you for Matt, who's helped us out today. Thank you for Ratchet for coming in. Thank you for Detricode. Thank you all, you guys. Honestly, it's been really awesome. I hope you all have a fantastic day, whatever you end up getting up to. Thanks for all the stuff, and I'll rest it later. Perfect. Yeah. So yeah, thanks for all the subs and stuff. If you subbed, I don't know. Yeah, I'll see you guys soon. All right then. All right, bye guys.